everyone, welcome to Simplilearn's AWS Full Course. Ever wondered who builds the tech backbone for companies like Netflix, Airbnb, or even NASA? That's the job of an AWS solution architect, someone who designs smart, secure, and cost-effective cloud system that powers the world's biggest platforms. Now, in this course, we are diving into everything to learn about AWS. From the basics to hands-on cloud projects, you will learn how to think like a cloud architect and even prepare for certification along with the way. So whether you're just getting started or brushing up your skills, this is your launch pad into the world of cloud computing. Let's build something amazing together. Just a quick information, guys, if you're looking to future-proof your tech career, then this professional certificate program in cloud computing and DevOps by E&ICT Academy, IIT Guwahati is your perfect choice. In just 8 months, you will gain hands-on expertise across AWS, Azure, and Google Cloud, master DevOps tools like Jenkins, Docker, Kubernetes, and work on 30+ real-world projects. What makes this program stand out? You get official Azure certification, IIT Guwahati issued credentials, access to live masterclasses, and even a campus immersion opportunity. Plus, with AI-powered job assistance, resume building, and interview preparation, you are set up for real career growth. So whether you're upskilling or making a career switch, this program offers everything you need to thrive in the world of cloud computing and DevOps. The course link is mentioned in the description box below and in the pinned comments.
We're going to talk about AWS here. By the way, I'm Sam. I work as a cloud architect and technical author with Simplilearn. In this section, we're going to talk about what is cloud computing and how things were before AWS. And we're going to talk about what is AWS and the benefits of AWS and the products and services that Amazon offers as of now. And then finally, we're going to end this session with a project that is going to help us understand how to create a Jenkins build server for continuous integration. And in this project, we will learn about how to deploy and host Jenkins, an open source automation software predominantly used for CI/CD, otherwise continuous integration and continuous development. So what is cloud computing? Cloud computing is the on-demand delivery of compute resources through a cloud platform accessed via the internet, and it's also a pay-as-you-go service. Be it compute capacity or database or storage in cloud, we access them through the internet, and that too on a pay-as-you-go pricing model. Let's talk about how things were before AWS existed. Expedia, as we know as the people logistic company or the company that helps people move around the world with ease, has a certain problem before they decided to migrate to AWS. And migrating to AWS was a solution to their problem. Back then, booking ticket was an unpleasant experience compared to what it is now. It generally would take a long time to book a ticket. And sometimes it would time out if there is a promotion or if a huge sale announced, and if the environment is not scaled up to meet the demand. And sometimes it would time out if there is a promotion or if a huge sale announced and they could not scale up the environment and keep up with the speed of the promotion. That's when they got introduced to AWS, and with the AWS power to increase the capacity of the environment on the fly, solved their scaling issue. Instead of waiting on the new hardware to arrive and wondering what to do with the hardware when the promotion is over, with AWS we can quickly scale up the environment when there is a need and scale down the environment during lull periods. Now, that being said, let's talk about what is AWS. Amazon Web Services, or in short AWS, is a secure cloud service platform offering compute power, database, content delivery, and other functionality that you would need to help your business scale and grow. AWS is a very secure cloud platform, and such security cannot be imagined in on-premises without spending a fortune. Almost any type of applications can be created and deployed in the cloud, which includes the latest IoT applications, machine learning, artificial intelligence, and so on. And the best part is we can avail the service from anywhere as long as we have an active internet. And all this is availed on pay-as-you-go subscription. Now let's talk about the benefits of AWS. AWS Cloud Platform is very easy to use. One needs no complicated programming or compute knowledge to access and use this environment. Even with less programming and compute knowledge, one could become a pro in accessing and maintaining the cloud. The products and services offered are very flexible in nature, and that provides room for us to easily integrate the service to other services in AWS and services outside AWS. Cloud in general is a very reliable service, and AWS in specific is very reliable. Cloud in general is very reliable, and when we talk about AWS, it's very true. A statistic says that about 95% of the cloud computing in the whole world is run on AWS due to AWS reliable nature. The services in AWS are scalable by nature, and most of the services provide click button scaling. Services in AWS are very cost effective, and it becomes very true when you start using more. Services in AWS are very cost effective, and it becomes very true when you start using more services in AWS are very cost effective, and it becomes more true when we start using more, since when we start using more service, the per unit price drops down even further. Security in the cloud is at its highest with encryption and multi-factor authentications and being able to audit the logs. One can be sure that when one hosts a service in AWS, they are hosting it in an environment which has been built with enterprise security in mind. Alright, let's now talk briefly about the different products and services available in the cloud. Some of the products and services available in the cloud are compute, storage, database, migration services, networking and content delivery, developer tools and services available for managing the AWS environment, tools needed for machine learning development, analytic tools needed for security and identity compliance, tools needed for mobile application services, tools needed for IoT and gaming development are some of the products that are available in AWS. Alright, let's first talk about compute service. Now, compute service, it enables us to develop, deploy, run and scale our applications and workloads on the cloud. You might agree with me that compute service is the fundamental of any applications, and AWS provides many options to use those compute services in the cloud, starting from EC2, which is a VM in the cloud, to Lambda, which is serverless computing in the cloud, to compute service. Compute service also includes container services and services that help batch processing and deploying applications and load balancing the request when we run our applications on multiple servers, and services that help batch processing and developing applications and load balancing the request when we run our applications in multiple servers. We're going to talk about two compute products in specific. Let's talk about EC2. EC2 is a service with a resizable compute capacity in the cloud that allows business subscribers to run application programs in the computing environment. And the best part here is EC2 is resizable. Anytime there is more demand, I can simply resize my computer to meet the demand. On the other hand, Lambda is a serverless compute service used to execute backend codes. It really helps us to focus on the core competencies like application building the code. Let's talk about storage service for a while. AWS storage is known for its durability and availability, with S3 being the object storage for the internet, where users or application can directly upload and download the content from the internet, and EBS being a durable block storage that gets attached to the EC2 instance, and Glacier being the archival solution in the cloud, and Storage Gateway being the gateway for storing data locally and having a backup in the cloud in case of disaster. Let's talk about two important storage service products in the cloud, which is S3. Now, S3 is an web-based cloud storage service. It's designed for online backup and archiving of data. And the best part about S3 is that it provides 11.9 durability, which means once we store the data in S3, the chances of losing the data is nearly zero. EBS, on the other hand, provides persistent and resizable and migratable storage to the VMs or EC2s that we can run in the cloud. Now let's talk about the database offerings in the cloud, beginning with RDS for SQL and DynamoDB for NoSQL and ElastiCache for web caching services and Amazon Redshift for petabyte scale data warehousing services. AWS Database Service provides all the database service needs we might have. Let's talk about two database services in specific. RDS. RDS is an web service that is designed to simplify the setup, operation, and scaling of the relational database in the cloud. And DynamoDB is a fast and flexible NoSQL database service which is well known for its low latency and scalability performance. Network and content delivery service contributes to the infrastructure as a service side of the cloud. It provides a secure cloud infrastructure and connects our physical network to our private virtual network with low latency and high transfer speeds. And under networking and content delivery services, VPC is virtual private cloud networking in the cloud. Route 53 is the DNS service in the cloud, and Direct Connect is a service that connects our on-premises with AWS environment through point-to-point cables. And CloudFront is content delivery network or caching service throughout the world. Let's talk about VPC for a while. VPC, it enables us to launch AWS resources into a virtual network that we define in the cloud. VPC resembles very similar to our office network with subnets, firewalls, private zones, public or DMZ zones, and a lot more. We can also create a VPN connection between on-premises and cloud environment through this VPC. And Route 53, it is a scalable and highly available domain name system web service that helps to route the end users to the internet application. Now AWS is a domain registrar as well, and here we can buy domain names for our organization and use them to mask the IP addresses behind it. And by the way, if you didn't know already, DNS is the one that translates human readable names like www.xyz.com into the numeric IP address. Let's talk about developer tool services. Now, developer tool services in Amazon provides services where developers can store an application source code and automatically build, test, and deploy applications on AWS, out of which AWS CodeStar enables us to quickly develop, build, and deploy applications in AWS. And Code Build is a fully managed build service that compiles source code, runs tests, and produces software packages that are ready to deploy. And Code Deploy, on the other hand, is a service that automates software developments to a variety of compute services, including Amazon EC2, Amazon Lambda, and even instances running on premises. And AWS Code Pipeline is a continuous integration and continuous delivery service for fast and reliable application and infrastructure updates. Let's talk about CodeStar. CodeStar is a service designed for developers where they can quickly deploy, build, and develop applications on AWS. AWS CodeStar provides a unified user interface enabling us to easily manage our software development activities in one place. With AWS CodeStar, we can set up our entire continuous delivery tool chain in minutes, allowing us to start releasing codes faster. And not only that, AWS CodeStar makes it easy for you or your whole team to work together securely, allowing you to easily manage access and add owners, contributors, and viewers to our project. And not only that, AWS CodeStar project comes with a project management dashboard, including an integrated issue tracking capabilities provided by Jira software. With the AWS CodeStar project dashboard, we can easily track progress across our entire software development process, from our backlog of work items to teams' recent code deployments, so on and so forth. AWS Code Build, on the other hand, is an cloud service that enables an IT developer to build and test code with continuous scaling. Now here you pay only for the build time that you have used. Now Code Build is a fully managed service that helps compiling source codes and run tests and produce software packages that are ready to deploy. With AWS Code Build, there is no need for us to provision, manage, and scale our own build servers. Code Build scales continuously and processes multiple builds concurrently. So our builds are not left waiting in the queue because it's processed concurrently. Let's talk about security, identity, and compliance services available in Amazon. In general, the security, identity, and compliance services in Amazon helps us to maintain a secure environment in Amazon by providing services for user authentication, for limiting the access to certain set of users on the AWS environment, out of which IAM, or Identity and Access Management, it's a product that enables us to manage access to AWS services and resources, that enables us to manage access to AWS resources and services in a secure fashion. Using IAM, we can create create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. On the other hand, KMS or Key Management Service is a managed service that makes it easy for us to create and control the encryption keys used to encrypt our data. And Cognito, it lets us to add user sign up, sign in, and access control to our web and mobile apps quickly and easily. And WAF or Web Application Firewall helps us to protect our web applications from common web exploits that could affect application availability, that could compromise security or consume excessive resources. And WAF, it gives us good control over which traffic to allow or block to our applications by sort of defining customizable web security rules. We can use WAF to create custom rules that block common attack patterns such as SQL injections or cross-site scripting, and we can also create rules that are designed for our specific application. Out of all the four, identity and access management, it helps us to control access to AWS services and resources for our users. With the identity and access management, I can restrict user access or I can give a user complete access to the environment. If it's an admin, I can assign complete access, and if it is a user, I can provide some privileged access or less or degraded or no access depending on the role that the user plays in the organization. And KMS is a service that helps us to create and control the encryption keys used to encrypt the data. And also we can use hardware security model HSM to protect the security of our data in the cloud. Also, we can use hardware security model to protect the security of the key itself. And let's talk about the management tools and services available in Amazon. Management tools and services, it helps us to manage, monitor, and automate all the resources running in the AWS infrastructure, beginning with CloudWatch, a service which monitors the environment by receiving logs and creating a dashboard and sending alerts as needed, and CloudFormation, a service through which we can deploy new environments using just templates, and autoscaling, a product that lets us to handle the dynamic traffic with ease by dynamically scaling up and scaling down the environment as needed. And CloudTrail is another product or another monitoring tool that helps us to monitor or collect the logs of all the API calls to our environment and provides a searchable tool based on keywords and timestamps. Let's talk about CloudWatch a bit more detail. Now, CloudWatch is a monitoring service for AWS. With CloudWatch, we can track the metrics, we can collect and monitor log files, we can also enable CloudWatch to set alarms and automatically react to changes in the AWS environment. CloudWatch can also monitor AWS resources such as EC2 instances, DynamoDB tables, Amazon RDS instances, as well as custom metrics generated by your application and services and any log files your applications would generate. Now, we can use CloudWatch to get a system-wide visibility into resource utilization, application performance, and operational health. We can use these insights to react and keep your applications running smoothly. And CloudFormation, on the other hand, provides a common language for us to describe and provision all the infrastructure resources in our cloud environment. Now, CloudFormation allows us to set up and model all our AWS resources so that we can spend less time in managing those resources and more time on our application. Now, CloudFormation is really an infrastructure as a code service where I can build an infrastructure based on the portable template I might be carrying. Alright, in this demo session, we'll talk about how to install Jenkins on Amazon Linux EC2 instance. And before that, let's talk about what is Jenkins and what is the purpose of it, why it is used, and all that stuff. Now, what is Jenkins? Now, Jenkins is an open source automation server, and it provides a lot of inbuilt plugins for deploying and automating any project. In short, it's an continuous integration server, and it is used for many purposes, used for tasks that take care of continuous deployment and delivery. And it provides these advantages like the developer now will not have to focus on fixing errors because errors are automatically handled by Jenkins, and because of that it leads to faster development environment. Alright, so how do we go about doing it? Let's get started. The first thing is to go to our console and launch an EC2 instance. Actually, let me walk you through the steps through the PPT and then I'll show it in the console. So let me first walk you through the steps in installing a Jenkins server. In this lab, we're going to launch an VM or a virtual application server to host our Jenkins installation. And then we are going to deploy Jenkins on top of it and then configure it as an build server. And for this, we will need an AWS account to begin with, and then a bit of experience in Jenkins, and then some familiarity on EC2 and how EC2 gets connected to VPC, stuff like that. So when we're all done, this is how the architect is going to look like. Users, they get connected to EC2 instance, which is a Jenkins server, and then there are slaves, build slaves that can be monitored, that can be used in deployment by the Jenkins server. So let's see how it is done. Alright, so let's first launch a server. Let it be an Amazon Linux instance. I'm going to pick T2 Micro because of the free eligibility, and because this is a lab, that should be more than enough. And I'm going to keep this as default. I'm going to stick with the default VPC, and I'm going to keep all the settings as defaults. And then I'm not going to add a storage. I'm going to keep the storage limited with the root volume. And then for security group, because we're going to access it through the internet, I would like port 80. In fact, since this is a lab environment and since I'll be tearing it down right after the lab is over, we're going to use all IP, or we're going to use anywhere, all traffic, anywhere. View and launch. And I already have a key pair that I have created. If you're not familiar with creating key pair, launching EC2 instance, you might need to spend some time watching the AWS EC2 video. That would help. So I already have a key pair that's attached to this account in this region. So I'm using that key pair to launch the instance. Alright, and that's my Jenkins server. Alright, so once that is installed, let's log into it. Since this being an Linux instance, I'm going to use putty to log in, and then use the key pair that we have downloaded to log in. And the key pair was right here. Alright, now I'm connected to it. As first thing, we will have to install the Java environment. I'm going to show some commands towards the end. So if you're planning to do labs yourself, you can use those commands. They will be very handy. In fact, I can show it right now as we speak. So these commands are to install Java environment. And it has two versions as we speak, and I've chosen the latest version. So I've typed 2 and I've chosen the latest version in installing Java environment. The second is to install Apache Maven. Let me show you some commands that's used to install Apache Maven. And these commands vary from Linux version to Linux version. So if you're using a different Linux version, just be sure that you're using commands which are respective to that particular version. All right, let's install Apache Maven. Looks like some of them are already installed and it's throwing error for some, but anyway, it's considered an successful installation. And then let's install Jenkins. And the commands to install Jenkins is right here. So these are to install Jenkins, and to download the software and install it, and then start the Jenkins and make sure the Jenkins stays running even after a reboot. So let's run these commands. Alright, now Jenkins should be ready, or the Jenkins server is installed in our EC2 instance and it is ready for us to access. And the default port is port 8080. So let me go to the URL or IP. Let me go to that and then try accessing it using port 8080. There you go. So at the moment it's locked. It requires admin password to log in, and the admin password is present in this particular folder and this particular file in the Linux instance. So let me get that. Okay, one moment. Looks like the admin password is not present. Just give me one quick moment. Okay, it's just a permission issue. Let me check the password in that folder again with the elevated permissions. There you go. There's my password. Alright, once we're logged in, we can install all the suggested plugins. Now that's going to take some time to run and install all the default plugins needed to run a Jenkins server. Alright, it's done. Now, as next thing, it's going to ask for the admin username and password. You can choose as an existing administrator, or you can also create another admin user. In this case, I'm going to create another admin user. Alright, so the Jenkins server is installed. We can use the similar but slightly different procedure on the Jenkins nodes or the slave servers to make them Jenkins slave and respond to the builds that we push, or receive the builds or receive the jobs that we push through this Jenkins server. So we have built this Jenkins server on Amazon EC2. A similar and slightly different procedures can be followed to build Jenkins build servers that can contact Jenkins server to receive jobs and start working.
Let's dive straight into the top AWS services. So guys, our first service is Amazon EC2, which stands for Elastic Compute Cloud. So basically what it is, Amazon EC2 basically lets you rent virtual computers, which is servers, in the cloud. You can use them to run your applications without having to buy your own physical servers. And you'd be questioning that why this service is so important. So guys, the reason is that businesses no longer need to invest in expensive physical servers, which can be difficult to maintain and scale. So EC2 allows companies to adjust their computing power based on the current needs, ensuring they only pay for what they use. This flexibility helps companies to save costs during low traffic periods and manage high demand during peak times, all without worrying about maintaining physical infrastructure. Now, let me propose a case study where a company named Airbnb used EC2. So guys, this was the challenge. Airbnb experienced issues with scaling during high traffic periods, such as holidays and during major events, which leading them to system slowdowns and potential outages. Managing their own server was very costly and time consuming, as they had to predict demand and manually add capacity, which often led to over and under poisoning. Now, I'll explain what over and under poisoning is, but let us first look at what are the issues they faced. The first one, they had the scaling issue, which means that high traffic periods during holidays caused slowdowns and outages. Then there was a problem of server management. Managing physical servers was very expensive and complex. Then they had unpredictable demand. It was very hard to predict traffic spikes, which led them to capacity problems. Then there was manual capacity addition. It also required manual intervention to scale up during their resources. And finally, they had over or under poisoning, which meant that often they had many servers or few servers, which led to wasting resources or causing slowdowns. Now, what was the solution, guys? So after moving to Amazon EC2, Airbnb could automatically scale its infrastructure up and down based on the demand. EC2's pay-as-you-go model allowed them to avoid the cost of over-provisioning and handle peak traffic seamlessly. So guys, there is some statistics which I want to share, that Airbnb infrastructure scaled up by 3x during the peak period using EC2's auto-scaling feature, which led them to zero downtime during high-demand seasons. They also reduced infrastructure costs by 20% by paying only for the capacity they needed. Now, let us move to our second service. So guys, our second service is Amazon S3, or Simple Storage Service. What it is, guys? Basically, Amazon S3 is a cloud storage where businesses can store and retrieve any amount of data like documents, videos, and backups. Why it was important, guys? Basically, S3 provides virtually unlimited secure storage that automatically scales with your needs. It eliminates the need for businesses to purchase and manage physical storage hardware. S3 also integrates easily with other AWS services, making it a key component for storing large amount of data like backup application files or even media streaming content. Its high durability is around 99.99%, which ensures that your data is safe and always accessible. Now, let us look at a case study of Netflix. So guys, during 2012, Netflix faced a massive outage due to a failure in their data storage system, resulting in downtime that cost them millions in lost in revenue. Their existing infrastructure could not handle the massive amount of content that required constant maintenance. Now, there are some of the problems with Netflix faced. The first one is massive outage, which means that Netflix experienced a major data storage failure in 2012. Then they had to go through a significant downtime. This outage resulted in millions of dollars in lost revenue. They had inadequate infrastructure. Their existing storage system couldn't handle the large content volume. Then there was scalability issues and also constant maintenance. The infrastructure struggled to scale up with the growing user demand and also caused them a lot of problems. Now, after migrating to Amazon S3, Netflix was able to store massive amount of data. S3's scalability allowed Netflix to handle global content distribution without interruptions or data loss. Now, let me show you some statistics, guys. So, Netflix now streams to over 230 million users globally, with S3 handling 1000 petabytes of video content, approximately. The switch to S3 reduced Netflix data loss risk to near zero and downtime dropped by 90%. So guys, this was one of the case study where Netflix used S3 and this was the amazing result that they got. Now, let us see one of the next Amazon Web Services, which is Amazon RDS or Amazon Relational Database Service. So what it is, guys, RDS is a managed database service that takes care of setting up, maintaining and backing up databases for you. Why it is important, guys? Because managing databases can be time consuming. It involves tasks like software updates, backups and scaling. RDS automates these tasks, freeing up valuable time for businesses to focus on the other core activities. With features like automated backups, multi-zone availability, and easy scaling, RDS helps businesses to ensure their databases are always running smoothly and securely, without the headache of manual intervention. Now, we'll take again the example of Netflix. So guys, during this phase also, Netflix suffered from a critical database outage, leading to a data corruption and millions in losses. Managing on-premises database was very difficult as backups, scaling, and disaster recovery required significant resources and manual effort. Now, these are some of the problems which Netflix faced. The first one was critical database outage, where Netflix experienced a major database failure. Then they had to go through data corruption, where this outage caused significant data corruption. There was massive losses because there was incident resulted in millions of dollars in losses. Then there were some on-premise challenges, like managing their on-premise database was very complex and inefficient. And there was also lack of automation because manual database management increased the risk of failure. So guys, by using Amazon's RDS, Netflix automated database backups, patching and scaling. RDS multi-agent deployment provided high availability and fault tolerance, which ensured that data losses during the failure outages are very minimal. Now, there is some statistics that Netflix reduced its database recovery time from hours to minutes in using RDS. Their database operational cost also dropped by 50% and due to the automated management features. So see how this service was very useful for Netflix. Now let us move ahead and try to understand our next service, which is AWS Lambda. But before we discuss this service, just a quick info, guys. Simplilearn has got Cloud Architects Master Program. You can master AWS, Azure, Google Cloud with the Cloud Architects course. You will build expertise in AWS, Microsoft Azure, GCP with the Cloud Architect Certification course. You will also receive exam vouchers, which is included on any Azure course. You will access official AWS authored self-learning content. Plus, you will also master cloud architectural principles, design, and also deploy scalable service on cloud platforms. So guys, hurry up now and join the course. The course link is mentioned in the description box. Now, let us move ahead in a discussion of what is AWS Lambda. So guys, Lambda lets you run your code in the cloud without having to manage servers. Basically, it automatically scales up when needed and only charges for the time your code runs. Why it is important, guys? Because Lambda allows businesses to run code without worrying about servers or infrastructure, paying only for the compute time used. This means companies can handle fluctuating traffic without having to over-provision servers, which means that it will help in saving cost and reducing complexity. Lambda is ideal for event-driven applications, where tasks are triggered based on the specific events, such as a file upload or a user action. Now, there is a company called iRobot, guys. So, iRobot needed to process large volumes of data from millions of Roomba devices worldwide. Managing servers to handle this real-time data was very complex and expensive, especially when usage fluctuated. Now, there was some problem, guys, with this, that they had high data volume, they had real-time processing problems, they had a problem of server management, then the cost challenges also came up and the scalability issues. Then iRobot adopted AWS Lambda's serverless architecture to automatically scale based on the number of incoming requests. They no longer had to manage servers or pay for idle time, as Lambda only charges for the exact compute time used. So guys, what was the result? That iRobot saw a 90% reduction in infrastructure cost by using Lambda's pay-per-use model. Lambda processed over 20 million events per day, scaling effortlessly without manual intervention. So guys, these were the success story of iRobot by using the AWS Lambda service. Now let us move ahead and discuss about our next service, which is Amazon CloudFront. So guys, what is CloudFront? Basically, CloudFront is a content delivery network that speeds up the delivery of websites, videos, and other data to the users around the world. Why it is important, guys? Because CloudFront reduces the time it takes to deliver the content to users, particularly those located far from the origin server. This is crucial for businesses that need to provide a fast and seamless experience to global audiences. Whether it's delivering videos, web applications, or large files, CloudFront ensures low latency access, improving the user satisfaction and engagement. So guys, you have heard about a company called Slack. Slack once experienced high latency and slow message delivery for users located far from their data centers. This created delays and inconsistent user experience, especially for global teams collaborating in real time. Now, let us see what were the problems faced by Slack. They had a problem of high latency, where I have told you that users far from Slack's data center experience significant delay in message transmission. The slow message delivery was there. Geographical impact was one of the problems, where the latency issues were more pronounced for global teams collaborating across distant locations. Then, if we talk about real-time collaboration, were also hindered. This delayed caused challenges for teams that rely on real-time communication, which finally affected and disrupting the workflow. And finally, they had inconsistent user experience. So guys, by implementing Amazon's CloudFront, Slack was able to cache and deliver content from edge location closer to the users, reducing latency and improving overall performance. CloudFront's integration with AWS Shield also improved security against potential DDoS attacks. Now, after using this service, Slack reduced the latency by 50% globally, providing real-time messaging to 10 plus million daily active users. They also experienced 40% faster file uploads and improved performance for international teams. So guys, this was the success story of Slack. Now let us move ahead and discuss about our next service, which is Amazon EBS or Elastic Book Store. So guys, what it is? Basically, Amazon EBS provides high performance storage for application running on EC2 instance. It is like a virtual hard drive that you can attach to your EC2 server. Why it is important, guys? Because EBS offers fast, reliable, and persistent storage for applications that require consistent, high-performance storage like databases or big data applications. Businesses can scale storage up or down as needed. EBS automatically backs up the data with snapshots, which ensures minimal downtime and data loss. So guys, there's a company called Expedia which faced performance issues with their existing storage system. It struggled to handle high volume of transactions during peak booking times, leading to slow response times and frustrated customers. They had performance issues, they had high transaction volume problem, like as I've told you, during the booking busy periods. Then they had slow response time where customer experienced slow response affecting their ability to complete bookings efficiently. Then they had the problem during the peak booking. They faced challenges where the problem was basically the performance issues. Now the customers were also frustrated. So what Expedia did was, Expedia migrated their databases from Amazon EBS, which offered consistent low latency performance and automatic scaling to meet high demand periods. EBS also provided robust snapshots backups for disaster recovery. As a result, Expedia improved booking transaction speeds by 35%, ensuring faster response time during their peak travel seasons. They also increased their data through output by 2x, supporting millions of daily searches queries without the delays. So this was a success story of Expedia, guys. Now you'd be excited to know the next success story. So our next AWS service is Amazon VPC, or Amazon Virtual Private Cloud. What is Amazon VPC? Basically, VPC allows businesses to create a secure private network in the AWS cloud, giving them control over how their data and applications interact with the internet. Why this is important, guys? Basically, VPC provides businesses with full control over their cloud network, including IP addresses, subnets, and security. It allows businesses to securely connect their on-premises infrastructure to the cloud and ensures that sensitive data is kept separate from the public internet. For industries like finance and healthcare, this level of security is critical for meeting regulatory compliance. What was the challenge, guys? So there is a company name called Capital One. Capital One needed a secure and scalable cloud solution to manage its sensitive financial data while meeting strict regulatory requirements. Their on-premises infrastructure was expensive to maintain and difficult to scale securely. So guys, they had problems like need for security, scalability challenge, they had a problem of regulatory compliance, they had high maintenance cost, and it was very difficult to scale securely. So guys, by creating an isolated virtual private cloud, Capital One securely migrated its application and data to AWS. VPC gave them full control over their networking environment, ensuring compliance with data privacy regulations while reducing infrastructure costs. Capital One basically reduced their infrastructure management costs by 30% by using the VPC. They achieved 99.99% of uptime for critical applications, thanks to secure, scalable cloud infrastructure of VPC. So guys, this was one success story of Capital One. Now let us look at another Amazon Web Service, which is Amazon IAM, or Amazon Identity and Access Management. What it is, guys? Basically, IAM lets businesses control who can access their AWS resources by setting permissions and user roles. It is important because IAM ensures that only authorized individuals can access sensitive resources, reducing the risk of security breaches. It's a critical tool for controlling access in large organizations where multiple teams need different level of access to cloud resources. IAM also supports multi-factor authentication, which adds an extra layer of security. Now, what is the challenge, guys, which a company named Autodesk faced? So Autodesk had a global workforce, and managing users to access various AWS resources was becoming very complex. They needed a way to ensure that only authorized users could access sensitive data and resources while maintaining security across the board. So they faced a problem of complex user access management. Then there was a need for authorized access. Then there was a global workforce challenge which Autodesk faced. Then they had to also maintain their security standards, and they had a problem of access control. They needed a solution on access control. where a more efficient and a scalable system was required by Autodesk to simplify and secure user access management across the AWS resources. So guys, Autodesk implemented AWS IAM to manage permissions and access control across their global team. With IAM, they created detailed user roles and policies, ensuring secure access based on need and reducing the risk of data breaches. So guys, Autodesk reduced unauthorized access incidents by 60% after implementing IAM. They decreased the time spent on access management by 40% thanks to the IAM's centralized control system. And that was possible. So this is how Autodesk solved this problem. Now let us move ahead and discuss about our next service. This is a very amazing service, guys. Its name is Amazon SQS or Amazon Simple Queue Service. Basically, Amazon SQS is a messaging service that allows components of systems to communicate with each other by sending and receiving messages between distributed applications. Why it is important, guys? Because SQS allows systems to scale independently by decoupling tasks, meaning different parts of an application can work on their own schedule without being dependent on one another. It's useful for batch processing, event-driven applications, and microservices. I know it sounds a bit of a technical jargon, but these are some of the scenarios where SQS is used. So guys, you have heard about this famous company called Disney+. Disney+ faced challenges in managing their large volume of user requests, especially during their release of popular shows and movies. Handling real-time requests without overloading the system was a constant issue. They faced problems like high user request volume, real-time request handling, then system overload risk was there because the platform constantly struggled with the risk of system overload during peak viewing times. Scalability challenges were also there because handling large number of concurrent users required scalable solution. And also consistent user experience means they ensure to have a smooth and uninterrupted experience for all the users during high demand periods, which was not happening. Now, Disney+ adopted Amazon SQS to queue and process tasks efficiently, decoupling their application components. This ensured that tasks such as streaming requests were processed smoothly, even during high traffic periods. And finally, Disney+ handled over 1 million requests per second during peak streaming periods, with SQS ensuring no message was lost. The use of SQS improved systems performance by 25%, enabling Disney+ to deliver uninterrupted streaming experiences. So guys, this is a success story of Disney+. Now let us move ahead and discuss about our final service. Can you guess it, guys? Yes, it is Amazon DynamoDB. DynamoDB is a fully managed NoSQL database service that is fast and scalable. It is ideal for applications that need to handle large amount of data with low latency. So this is the thing. Now you would be wondering why DynamoDB is important. So guys, DynamoDB is very essential for applications that experience rapid growth or fluctuating demand. Unlike the traditional databases, they might struggle to keep up the volumes of traffic, but DynamoDB can automatically scale up to handle millions of requests per second. This is just something which I told you. Let me elaborate this by the story of a company called Lyft. So guys, Lyft needed a database that could handle millions of ride requests in real time. But their traditional database systems could not scale efficiently to meet the demand, leading to slow response time during busy hours. They had problems like real-time data handling, scaling limitations they had high request volume, they had slow response times, and also they needed a scalable solution for this problem. Now, here comes the DynamoDB. Lyft switched to Amazon's DynamoDB, which provided fast, scalable, and serverless architecture with NoSQL database services. DynamoDB ability to handle millions of requests per second ensured that Lyft could match drivers with riders in real time without latency. Now, this is the thing which Lyft has seen. Lyft processed over 2 million ride requests per day with DynamoDB, scaling automatically to meet the peak demand. They improved the response time by 70%, ensuring a smooth experience for both drivers and riders. This is how Lyft solved this problem.
Hello everyone, welcome back to the channel. Today, I want to take you on a journey that could transform your career, much like how cloud computing has transformed some of the world's most innovative companies. Imagine Netflix, once a DVD rental service, transforming into a streaming giant capable of delivering high-definition content to millions of users simultaneously. Or consider Airbnb, which has used cloud computing to manage listings and bookings for millions of properties around the globe, providing a seamless experience for hosts and travelers alike. Both Netflix and Airbnb utilized cloud technologies to efficiently scale their businesses, manage large volumes of data, and ensure high availability and performance. So, by transitioning from traditional, costly, and inflexible on-premises infrastructure to scalable cloud environments, they significantly reduced cost, accelerated innovation, and improved user experience in real time. Now, you might think that working on such impactful projects requires years of experience and advanced degrees. But there's the good news, guys. With the right approach, you can start a career in cloud engineering in just 3 months, even if you are starting from scratch. In this video, I will outline a clear, actionable plan that uses entirely free online resources to get you there. We will cover the essential skills you need to learn, the certifications that can help validate your knowledge, and practical projects that will make your resumes stand out. So if you're ready to dive into the world of cloud computing and perhaps one day contribute to the next big thing in tech, so stay tuned, guys. So let's get started. And the number one point you should start with is starting your cloud journey. So transitioning into cloud engineering may seem daunting, especially if you are new to this field. The first step is understanding why this is a valuable career move. The cloud industry is booming with a projected market value of $800 billion by 2025 and the potential to grow even further. This growth means a constant demand for skilled professionals, making it an excellent time to enter the field. Now that we understand the industry's potential, the next question is, where should you start? So you should choose a cloud provider. So choosing a cloud provider is a critical decision as it shapes your learning path and future jobs opportunities. So the three major players are AWS, Azure, and Google Cloud Platform, GCP. So starting with AWS, so AWS, that is Amazon Web Services, is often recommended for beginners because it has the largest market share and a wide range of services, which translates into more job opportunities. Now coming to Azure, that is another strong option, especially if you're targeting jobs in enterprises that use Microsoft technologies. Now coming to GCP, that is Google Cloud Platform. And it is gaining popularity and offers excellent features, especially in data analytics and machine learning. For beginners, AWS is a popular choice due to its widespread use and extensive documentation. However, it's important to research the demand in your local job market and consider your own interest when making a decision. And with the cloud provider chosen, the next step is to build a strong foundation in the fundamental technologies that underpin cloud computing. So now, before diving into cloud-specific services, it's essential to understand the foundational technologies that cloud computing relies on. These include, number one comes networking. So understanding how data moves across networks is crucial for setting up and managing cloud infrastructure. Then comes operating systems. Familiarity with operating systems, particularly Linux, is essential as most cloud environments run on Linux servers. Then comes virtualization. So this is the process of creating virtual instances of physical hardware. That's a core concept in cloud computing. And then comes databases. So knowledge of databases, both relational and non-relational, is critical for managing data in the cloud. So with these foundational skills in place, you are now ready to explore cloud-specific learning paths. So let's start with certifications. So certifications can validate your knowledge and make you stand out in the job market. For AWS, starting with the AWS Cloud Practitioner Certification is advisable. This certification provides a broad overview of cloud concepts and AWS services. It covers key areas such as compute services, storage options, security measures, networking capabilities, and billing and pricing structures.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
And before moving forward, guys, I have a quick info for you. You can also check out Simplilearn's Microsoft Certified Azure Administrator Associate AZ 104. So this certification offers everything you need to boost your skills and credibility. You can dive into engaging learning modules, hands-on labs, and expert-led sessions that make mastering Azure a breeze. So in this course, you will learn to manage Azure subscriptions, secure identities, administer infrastructure, configure virtual networking, connect Azure and on-premises sites, and managing network traffic. So you can also check out the backup and share data and monitoring your solutions. And you can find the course link in the description box and pinned comment. Now coming back, while certifications are valuable, they need to be complemented with practical, hands-on experience to truly demonstrate your skills. Here comes building projects or hands-on practice. So building projects is the most effective way to apply what you have learned and to demonstrate your abilities to potential employers. So here are a few beginner-friendly projects to consider. Number one is setting up virtual machines. So start by launching an EC2 instance on AWS. Learn about the different instance types, configurations, and the basics of server management. Then comes the next project, that is cloud storage systems. So experiment with services like S3 for object storage and RDS for relational databases. Document the use cases and differences between these services. Then deploy a web application. Host a static website using S3 and CloudFront, which will teach you about web hosting, content delivery, and the basics of DNS management with Route 53. Initially, you can use the AWS console for these tasks, but as you progress, try implementing these projects using infrastructure as code tools like Terraform. This approach not only deepens your understanding, but also aligns with industry best practices. In addition to practical projects, having some coding knowledge can greatly enhance your capabilities as a cloud engineer. So now we'll see how you can learn to code. While not always mandatory, coding skills can significantly enhance your effectiveness as a cloud engineer. Languages like Python and Bash are particularly useful for scripting and automation. Even a basic understanding can help with tasks such as writing scripts for server automation, managing cloud services or resources programmatically, then implementing infrastructure as code. For those new to coding, check out Simplilearn videos on YouTube, which offers excellent starting points. Coding skills not only make you more versatile, but also open up opportunities to specialize in areas like DevOps or cloud native development. And once you have built your skills and some projects, it's time to start with the job hunting process. That is, building your profile. Creating a strong online presence is crucial when job hunting. Your LinkedIn profile should clearly reflect your new skills, certifications, and projects. So here are some tips. Number one is optimize your LinkedIn profile. That is, include a professional photo, an engaging summary, and detailed description of your projects. Then comes network actively. Connect with professionals in the field, join cloud computing groups, and participate in discussions. And then comes apply strategically. Tailor your resume for each job application, highlighting the skills and projects that align with the job description. Applying for jobs can be a number game, so be persistent. It's also helpful to reach out to recruiters or hiring managers directly to express your interest in the role. As you start to gain experience in your first cloud role, consider specializing in a niche area to advance your career. And then comes specializing and continuous learning. So specializing in a particular area of cloud computing can make you more valuable and increase your earning potential. Possible specializations include DevOps, that is, it focuses on automation, continuous integration, and continuous deployment practices. Then comes serverless computing, work with functions as a service, that is FAS, and other serverless architectures. And then comes security. Specialize in cloud security to protect data and infrastructure. The cloud industry is dynamic with new tools and technologies emerging regularly. So continuous learning is key, so stay updated through online courses, webinars, and industry news. Finally, remember that the journey into cloud engineering is continuous and ever evolving. So we talk about resources, so embarking on a career in cloud engineering is challenging but highly rewarding. Utilize free resources like YouTube tutorials, community forums, and documentation to guide your learning.
I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called Simplilearn S3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right, and now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. It says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create 2 users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM, Identity and Access Management. And on the left-hand side here, we're going to click on Users. You can see here I don't have much going on. I just got an administrator user, so I want to create 2 new users. We'll start with one at a time, so one called user1. Now, by default, we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now, and also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user, but I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3, star, and also object lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users. Make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user 1. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create, called user2-MFA, or MFA rather. All right, so now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here, assigned MFA device. We have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists, all right? So there's got to be a key value pair that exists, and there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. And I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. what I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder 1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user 1 and user 2-MFA, then let me just apply this. That would mean that user 1 would not be able to see the contents of our object inside folder 1, and user 2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user 1 and user 2-MFA and prove this is actually the case. So I am now logging back in as user 1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user 2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user 2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I've just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. A little painful for demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket. in question, and I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user 2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2. Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out, and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM, and we're going to be creating our first group. We're going to simply create the button or click on the button create group, and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, or in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one, or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission, for example, let's say based on DynamoDB, right? So I'm going to get full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show 2 more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across the accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us.
In today's job environment, being certified marks the difference between getting your dream job and losing it. If you're a fresher or just someone who's starting up, it's highly likely that you're confused in choosing the right certification. I'm going to help you figure it out. I'm Rahul from Simplilearn, and today we're going to talk about AWS certifications. So what exactly is an AWS certification? It represents a degree of expertise in AWS. It is obtained after passing one or more exams provided by Amazon, and each different role, like the SysOps administrator, developer, or solutions architect, has a different exam associated with it. This in turn helps employees demonstrate and validate technical cloud knowledge, which means that the people who are certified actually know what they're talking about. I have seen a common misconception among people where they believe that just because they're certified, they're entitled to a job. That's not true. Now, without proper practice or hands-on experience, the certification is wasted on you. So remember, just because you're certified does not mean you'll get a job. It only makes the job application process slightly easier relative to someone who's not been certified. Now, why is AWS given so much importance? Some of the important reasons are: an AWS certified individual gains credibility for their skills in AWS. They also gain access to free practice exams which help them prepare for the next AWS certification. There's an increase in monetary compensations, which only means that they get paid more, and you gain recognition for your knowledge and skills in AWS. Right now we're in the AWS certification website, whose link will be in the description, and now we're going to talk about the types of AWS certification. As you can see here, there are 3 levels of AWS certification. There's the foundational level, associate level, and professional level certification. Now, the foundational level certification only requires you to have a basic understanding of how the AWS cloud works. The AWS certified cloud practitioner is optional for the architect path, developer path, and operations path. It is mandatory for the specialty certifications like the advanced networking, big data, and security certifications. Now, the associate level certifications are mid-level certifications for a technical role. Now, a professional certification is the highest level of certification that you can have for a technical role. Now, you have the solutions architect for the architect path and the DevOps engineer certification for both the developer and operations path. So how do you decide which of these certifications is suitable for you? So you've seen here that AWS provides various certifications for a number of job roles like SysOps administrator, solution architect, developer. So you need to make the right choice, taking into consideration the areas of your interest and the experience level that you have. Now we're going to talk about each of these certifications in detail. So first, let's talk about the AWS Certified Cloud Practitioner. Now we all understand that AWS is a widely recognized product in the market. So this certification helps you validate how well you know the AWS cloud. So this is just the basic understanding. Now, it is optional for the developer path and the operations path. I would suggest it's a good idea to start here because it forms a solid bedrock on all the other things that you're going to learn soon. Now, more importantly, it does not require any technical knowledge of other roles such as development, architecture, administration, and so on. So it's a great place to start for newcomers. Now you have the architect role certifications. Now, this is for you if you're interested in becoming a solutions architect or a solution design engineer or someone who just works with designing applications or systems on the AWS platform. Now, first we have the AWS Certified Solutions Architect Associate Level Certification. Now, this certification is for you if you want to show off how well you can architect and deploy applications on the AWS platform. Now, it is recommended that you have at least a year of experience working with distributed systems on the AWS platform. At the same time, it's also required that you understand the AWS services and be able to recommend a service based on requirements. You need to be able to use architectural best practices and you need to estimate the AWS cost and how you can reduce them. Next up, you have the AWS Certified Solutions Architect Professional Level Certification. Now, you will not get this certification unless you're done with the AWS Certified Solutions Architect Associate Level Certification. This is to show off your technical skills and experience in designing distributed applications on the AWS platform. Now, this does require you to have 2 years of experience working with cloud architecture on AWS. At the same time, it also requires you to be able to evaluate requirements and then make architectural recommendations. You also need to provide guidance on the best practices on architectural design across a number of different platforms. The developer level certifications are for you if you're interested in becoming a software developer. Now, the AWS Certified Developer Associate Certification is to test how well you know how to develop and maintain applications on the AWS platform. It does require you to have a year or more of hands-on experience to design and maintain AWS-based applications. Like any software developer role, it is necessary that you know in depth at least one high-level programming language. It's also necessary that you understand the core of AWS services, uses, and basic architectural best practices. You need to be able to design, develop, and deploy cloud-based solutions on AWS platform, and you need to understand how applications can be created. You need to have experience in developing and maintaining applications for a number of AWS services like Amazon SNS, DynamoDB, SQS, and so on. Now for the AWS Certified DevOps Engineer Professional Level Certification. Note here that this certification is exactly the same as the one you have under the operations role. So both of them are the same thing. So here it tests your ability to create, operate, and manage distributed applications on the AWS platform. Now it is necessary or it is mandatory to have the AWS Certified Developer Associate Certification or the AWS Certified SysOps Administrator Certification with 2 or more years of hands-on experience in doing the same in AWS environment. It requires you to be able to develop code in at least one high-level language. You need to be able to automate and test applications via scripting and programming, and to understand agile or other development processes. The operation certifications are for you if you want to become a SysOps administrator, systems administrator, or someone in a DevOps role who wants to deploy applications, networks, and systems in an automatable and repeatable way. The AWS Certified SysOps Administrator Associate Certification tests your knowledge in deployment, management, and operations on the AWS platform. Now, you need to have 1 or more years of hands-on experience in AWS-based applications. You need to be able to identify and gather requirements, then define a solution to be operated on AWS. You need to be able to provide guidance for the best practices through the life cycle of a project as well. Now, the specialty certifications are for you if you're well versed in AWS and want to showcase your expertise in other technical areas. The AWS Certified Big Data Certification showcases your ability to design and implement AWS services which can help derive value from a large amount of complex data. You are, however, required to have completed the foundational or associate level certification before you can attempt this. You need a minimum of 5 years of hands-on experience in the data analytics field as well. Next, we have the AWS Certified Advanced Networking Certification. This validates your ability to design and implement AWS solutions as well as other hybrid IT network architectures at scale. This also requires you to have completed the foundational or associate level certification. You need to have a minimum of 5 years of hands-on experience architecting and implementing network solutions. And lastly, we have the AWS Certified Security security certification. It helps showcase your ability to secure the AWS platform. You're required to have an associate or cloud practitioner level of certification, a minimum of 5 years of IT security experience, and 2 years of hands-on experience securing AWS workloads. Now say I wanted to schedule an examination. So for example, I want to do the Solutions Architect certification. So first I would go there. Now here I can click on register now and the process continues, or I can click on learn more. By doing this, again I can schedule the examination here. I can also get access to other data like the number of questions available, the cost of an examination, the portions I need to study, and so on. Now let's talk about the Solutions Architect certification with a little more detail. Now this certification exam costs $150 and the practice exam costs $20. Now here I can schedule the examination or download the exam guide. I've already downloaded the exam guide and here it is. Now this exam guide tells you about what you need to learn and what is expected from you. Here they want you to define a solution based on requirements and provide guidance in its implementation. It is also recommended that you know about how the AWS services work, 1 year of hands-on experience with distributed systems on AWS to identify and define technical requirements, and so on. The rest is available in the exam guide. And most importantly, they tell you the main content domains and their weightages. Now we have 5 domains. First domain is to design resilient architectures, which holds 34% of weightage. At domain 2, you have to define performant architectures. 3 is to specify secure applications and architectures, cost optimized architectures, and 5 to define operationally excellent architectures. Now, like you've seen here, we've selected one certification and learned it in detail. You can do the same for any of these other certifications. You can press learn more and download their exam guide and learn everything that you need to know.
So the idea is services and below services data centers. Simple. Everything is managed by AWS and that is called as cloud environment. Basically, it is a third party cloud, right? So it may happen that, there are different models of cloud computing, I can say. Suppose the same example of Raj and the IT company who got the business from Mr. Raj. So there can be 3 possibilities that they can do this. Number 1 possibility is that IT company will self-manage the data center. They will manage their own data centers, virtualization technology. These are all managed and maintained by the company. If it is done by IT company itself, then it is called as private cloud model. Second, if they don't have any plan to create their data centers, but they would like to use third party such as AWS or even second is Microsoft Azure or Google Cloud, whatever. But they would like to use third party cloud. So third party means they are not creating data center or managing data center and virtualization technologies. Basically, they want to rely on different companies who will work for them. So that is third party cloud. So there are major market players in this game. One is AWS, which is a major market shareholder, followed by Microsoft Azure, and then followed by Google Cloud. This is called as public cloud model. So what we are learning, public cloud by AWS. So any customer can go to public cloud because their whole infrastructure depends on third party data center and their services. So IT company will not maintain anything from their side. And the third is called as hybrid. So in hybrid, it is a combination of public and private cloud. The third one. So hybrid cloud model may have certain percentage of workload on personal data center. So I can say data center by IT company and data center by third party cloud such as AWS. So certain percentage of workload is on own data center and certain percentage of workload on AWS data center. So this combined model is called as hybrid cloud. Hybrid cloud is adopted by companies where their compliance and governments do not allow them to have 100% cloud. I give you simple example. Initially, banking sector, when cloud computing started, banking sector entered into cloud very late. Do you know that? Because banking sector had a lot of compliances and governance, wherein as per their compliances, they have certain restriction that they can't deploy everything on cloud model. So certain resources, for example, let's say the virtual machines are running on their own data center. Maybe storage is running on AWS. So they are using storage service of AWS, but virtual machines are maintained by themselves, their own VMs they are using for launching the website. But storage device they are using from AWS side. So this is kind of hybrid cloud. So wherever companies have compliances issues, which do not allow them to deploy 100% workload on AWS, then that they go with the hybrid cloud also. So these are the three possibilities: private cloud, public cloud, and hybrid cloud. So as I explained you, um, different services of AWS like this, different services are there. But these services are running over different set of data center in the world. What are the locations available? I can show you on the right side. This right side list is a list of regions of AWS. And I can show you these regions starting from US East, Northern Virginia, US East, Ohio, West, Northern California, US West, Oregon, Asia Pacific, Mumbai, Asia Pacific, Osaka, Seoul, Singapore, Sydney, Tokyo, Canada Central, Europe, Frankfurt, Ireland, London, Paris, Stockholm, South America, different Africa, Asia Pacific. You could see that a lot of regions are there and they are actually covering up a lot of countries. Do you want to see the real view of those regions? So what I can do is, first of all, I would like to show you an image of AWS data center. How a single AWS data center looks like. And for that purpose, I can, show you one YouTube video, which is an official AWS videos, I believe. Let us see that first. There's a documentary, I think. Let me try switching my internet to some other network. Yeah. I hope this is visible to you. Different companies are the customers you can see on the screen. There was one official video also, which I will show you after this, which actually gives you a very good idea. How does these are the actual footages of their data centers being managed by different employees. They have provisions for crisis management also. You can read the scripts also. Cameras for physical surveillance. A data center is a very important part because attackers or visitors, they may, there could be intrusion detection at the very moment. And yeah, so I think you're getting fair idea. How does it looks like? I wanted to give you a visual appearance of the data centers of AWS. These are basically buildings, warehouses, where AWS is having a setup of these hardware servers. And there are many hardware servers inside single building. So this is one data center building you could see. Now I would like to show you some interesting things. This is actually a graphical image of a data center. And yeah, so then the question is how many such buildings they have maintained in the world. So the number is not known to anyone, but they have many buildings, many data centers in the world. And the areas, the regions where these data centers are set up are shown on this particular image. You can see this is the world map starting from United States. So one is like Northern Virginia, which is the first region. Then you have Government Cloud, Ohio, Mexico, Government Cloud again, Oregon, Canada West. You have Cape Town. In the Middle East, Kingdom of Saudi Arabia. Then this is Bahrain, I believe, UAE, Tel Aviv. You have Spain in Europe, Paris, Ireland, London, Europe, Stockholm, Milan. In Asia, you have Mumbai and Hyderabad. This second is Hyderabad. In China, you have Ningxia, Hong Kong, Beijing. You have Thailand, Singapore, Malaysia. Australia, we have two, Melbourne and Sydney. We have Auckland in New Zealand, and then we have Tokyo and Osaka in Japan, Seoul in China, and you could see that. So total 33 geographic regions are available, and they are colored in two colors, green and red. Green colors are the one which are existing regions. Regions represent AWS presence in that country. So for example, in Australia, Sydney is the region. So inside Sydney region, there will be many data centers. It's not indicating one data center. There will be multiple data centers in that Sydney region. And those data centers together are representing the AWS presence in that country with the name Sydney. So probably somewhere nearby Sydney city, there will be a lot of data center placed. And as such, there are 33 regions. So AWS is spreading their business all over the world. They are approaching new countries because their customers are increasing. That's what they're doing the business for. And as the customers are increasing, as there is a demand from customer from a particular section of a country or a world, then they start creating their own data centers in that place so that they can provide the services very fast. However, you could see that red colors are indicating coming soon, which are the future plans. They are in progress right now. Probably once they announce that Mexico is coming soon, so within a year they will be making it available for usage. So you can see the list also. Different regions available as per the different regions. So this is one of the very important aspect of AWS physical infrastructure, or you can say that global infrastructure. The bigger entity in this global infrastructure is called as region. And I take example of Sydney. I can draw one circle. Let us assume that this is a Sydney region. Now inside Sydney regions, there will be multiple buildings which are nothing but data center. So here I have drawn 4 data centers. But here I am drawing another group of data center. And you could see that I'm purposely placing this data center in another groups. So what I'm doing is I'm creating groups of data center in my diagram. Why? Because this is the way data centers are placed inside a region. Inside Sydney region, there will be groups of data center, right? And those groups of data centers are called as availability zones. So now these three green colors are actually called as availability zone. So this is availability zone A, this is availability zone B, and this is availability zone C. So you might be wondering that why there is a requirement of grouping of data center inside region. Why can't we have a single group of all the data center and we call it as region? Why not? So there is a very, very big thought behind it. This big thought is related to availability of your resources, and this is called as high availability. Now, what is this concern? I'll tell you. First of all, what AWS does is they make groups of data center which are far from each other. So if you try to see the distance around 60 miles or 100 kilometers, you can say roughly, they try to maintain this much space between each group. So suppose there are three groups inside Sydney, there are three availability zones. So between two availability zone, there will be a gap of 60 miles or 100 kilometers, 100. Why there is such big distance between them? Because AWS is purposely doing this in their infrastructure. AWS has set up this infrastructure purposely because they would like to maintain one important thing which is called as high availability. Now, this is something is very important to know for everyone sitting here. High availability. All right. Let's say so Claudia is doing good business online, and Claudia has made a very nice website, and the website is running on AWS cloud. Okay. So obviously some virtual machines, we want for that website. Suppose we have created one virtual machine of using EC2 service. So this red color is my virtual server on which Claudia's website is running. Okay. So while creating virtual server, you have to choose availability zone. So I have chosen availability zone A. In that, my website, this EC2 machine is created. So when this machine is created, actually, you can see how many data centers are there. There are 4 data centers inside AC. So this machine will be running on each data center. This is called as redundancy. Redundancy means rather than running the machine on one data center, they run it on multiple data center within the availability zone. So for Claudia, how many resources are there? Can you tell me from user side? Our user is Claudia. So from Claudia's perspective, how many resources are there? How many machines Claudia has made? So for Claudia, it is only one machine that is being run. Okay. And Claudia will be paying for only one machine. But actually, inside availability zone, I have drawn 4 data center, but we don't know how many data centers are there inside availability zone. There are multiple. There can be 2, there can be 4, there can be 10. We don't know. So the machine is running in all data centers, so that if one data center is not responding, in case there is some problem in one building, one data center is not at all responding, then another data centers are having the same machine running. So this will act as a spare machine. But if the problem is bigger, imagine there is an internet outage in the same area. So we know that within one availability zone, all the data centers are nearby each other. It's a group. So if there is an internet outage will be there for all 4 data centers. If there is a very big issue of electricity, there is an issue of natural calamities. If I'm talking about, let's say, flood, earthquake, anything wrong happens, right? So if the problems are there in that particular area, then it will be impacting all the data center in that availability zone. So I'm thinking of, imagine in Sydney, there is one area. Okay. See, this happens because we need to focus on the explanation. I am repeating it. In Sydney, we are focusing on availability zone A, where Claudia's machine is running. We are just focusing on availability zone A, where Claudia's machine is running. All right. So what I'm saying is, if there is some bigger problem in that area where your availability zone is there, suppose there is a big issue of electricity, so it will be impacting all the 4 data center. So we are thinking about failure situation. We are thinking about, some disaster. Suppose there is some internet outage in that particular area, so it will be impacting all the 4 buildings. If it is there is some big issue of earthquake, it will be impacting all the 4 buildings. So what I'm thinking is, if this is going to impact all the 4 data center, then your website will be down because all the 4 copies will be down. Your EC2 is not available. So that is why when Claudia will make the machine, we will recommend Claudia to not create one machine. We will ask Claudia to create multiple machine. So multiple means 2 or more than 2. So suppose Claudia agreed upon creating 2 machines. So one machine will be created in one availability zone and another machine will be created in another availability zone. So you can see there are 2 EC2 machines Claudia has made, but while making it, we have created these 2 machines in different availability zone. One is in availability zone A, another is in availability zone B. So if there is a problem and in the first availability zone, the first availability zone data centers are not working, they are not responding, it means this website is down on this particular machine. If this group of data centers are not responding, then the machine which is in availability zone will be down. People will not be able to visit the website. But what about second machine? Is your second machine is in availability zone or availability zone B? In A or B? It is in B, right? And there is a gap of 60 miles, 100 kilometers. So do you think the problem of A, is there any chance of impact of that problem on B? No, because we have purposely kept distance. AWS has purposely kept distance between the 2 groups. If one group has some problem, there's a less chance that second group will be impacted. And that is why the second machine will be still up and people will be able to visit your website anytime. Does this make sense? This phenomenon is called as high availability. This phenomenon is called as high availability. Your websites will be highly available even in the failure situation. And this is possible. How I have made it possible? I have made it possible by using multi-AZ approach. Did I use multiple availability zone for launching my website? Could you answer this? Did I use multiple availability zones? While launching the machine, I launched 2 machines. I launched 2 machines not in one availability zone. I launched it in multiple availability zones. And this is why multiple availability zone leads to high availability. Would you be able to remember this formula? Multi-AZ leads to high availability. So this is a strategy. We never depend on one resource. We depend on multiple resources because other resources act as a spare. Suppose I go to exam hall, instead of carrying one pen, I'll carry 2 pens or 3 pens with me because I know that if one get filled, I'll be completely down. So better than that, carry another pen also, which will help us to write down the answers. And that is how multi-resource approach in multiple availability zone help us to achieve high availability. And this is all called as AWS global infrastructure part. So most interesting part that you should know is that each data center is connected to each other through fiber optic cables. There is a network of fiber optic cables which is landed among all the data centers of AWS. So you can see this is a network within Sydney. all the data centers are connected to each other through fiber optic cables. So as such, there are many data centers in many regions. So this is Melbourne, this is Sydney. So all these 33 regions, similar to Sydney, all the data centers in those 33 regions are connected to each other through fiber optic cables. So AWS has transocean cables lying underlying or underground below the sea, and it is all connecting all the data center in all the regions of AWS in the world. That network is called as AWS private network. So this is the blue line that I'm using. AWS private network is a network of all the data center of AWS on the planet, and they're all connected through high-speed transocean fiber optic cables, which help us to transfer the data between two services very fast. The AWS private network helps to transfer the data between two services within multiple regions, same region, very fast because they travel through this private network of AWS. Can we use availability zone in different regions in multi-AZ? It means his question is, let's say I'm launching my one website in Sydney region and another website in, let's say, Northern Virginia. So this is Sydney and this is Northern Virginia region. So he says that I will launch one website in one availability zone of Sydney, and I will launch one website in another availability zone of Northern Virginia. Can you do this? So the answer is no. We don't do architecture like this. Whatever we launch the project, we launch it inside one region only. So what you can do is you can use another availability zone in that Sydney region, and you can launch your second machine inside that. Or you can use another availability zone of Sydney. Let's say this is AZB and this is AZC. And inside AZC, you can launch third machine. So all the machines belonging to one project, you should launch it in one region only. Cross-regional thing is not possible. Arvind Kumar, I hope you got the answer. And you will get it when I will teach you EC2 service, when we'll do a lot of demos. I will revise all these concepts once again. So, conclusion. We discuss about cloud computing models. Before that, we talk about introduction to cloud computing. We discuss about AWS, we discuss about cloud computing models, and then AWS global infrastructure. In that, we know what is meant by data center, single building. Then we know what is meant by availability zones, group of data center in one area, and what is meant by region. Region is a group of availability zone in the particular country. And we have seen that high availability we can achieve with the help of multi-AZ setup. What happens if I use one AWS account, how the pricing is done? So basically, AWS follows the model of pay as you go. It means how much you are using, that much you have to pay. Let's say I'm creating one virtual machine and my virtual machine is running for 10 hours. So then after 10 hours, I'm deleting that machine. I'm going to terminate that resource. So for those 10 hours, my machine was up. So I have to pay the charges of the machine only for the usage I did. So I use it for 10 hours. I have to pay the charges for 10 hours. That's all. So companies can easily create resources on demand and they can terminate the resources as per their wish on demand. So whenever they want to scale their infrastructure, want more resources, they can purchase, they can create those resources. And whatever time they are using the resources, according to that, every service has different pricing model. And then your total pricing is calculated and you get monthly bills. So do you know monthly bills? You can use the account for 1 month whatever services you are using for how much duration. Accordingly, different pricing models are there. Then they calculate your bill and they generate the bill by the end of the month. So you have to pay it. In fact, the good part is when you become a first new customer of AWS in their account, they give you free quota. Are you aware of this free tier quota? Certain usages are free. So being a student of AWS, being a learning student, or you're doing it for your personal use, I believe you can go with the basic plan. And with the basic plan, you will get certain free tier quota where a lot of things will become free of cost for you. So practically speaking, you will not get bills if your usage is under the free tier quota. So that is why it is very, very interesting to start with AWS, and companies are finding it very good model, pay as you go, because they can control the cost as well, and they can control the cost as per their usage as well. So this is what we have learned. This was the introduction to AWS and global infrastructure. You have the idea of data center, availability zone, regions, multi-AZ, high availability, everything. Now we are going to a core technical part where, first of all, I will teach you about AWS account. What are the different ways to access AWS account? AWS account is a free account that you can create for you personally, or as a company, you can use business plan and create an AWS account for launching your client's resources. And how to create an AWS account is a very simple process. In case if you want to create your own personal account, then you need to visit a website called aws.amazon.com. This is the name of AWS website. Once you open this, on the top right corner, you can see there is an orange color button, create an AWS account. So this is a sign up page. On this sign up page, you require one email ID, and you need to provide that email ID here, a@r.com. So this is the dummy email ID I have mentioned, but I want you to mention in email ID. Then you can use some account name. This email ID is very important because this is used as a owner's email ID. This will be your root email ID. And this is very, very important to recover the account also. To log in into account, to recover from the account, everything. So make sure you are giving the email ID you have the access to. So then you need to click on verify email address and you get one verification link on your email. If you click on that link, then your email will be verified. After that, they ask you personal information. What is your full name? What is your mobile number? What is your address? And which type of plan you want to go with. So you should go for basic plan. Basic plan is a simple plan of AWS that comes with the account without any additional charges. And that plan is suitable for small scale businesses, startups, even for community of AWS, people like us who are working on AWS project, who are learning the AWS system. So we all should go for business this basic plan. Apart from basic, there is business and enterprise plan also. So basically, business plan and enterprise plan are giving the same account, same resources, but they are giving extra support from AWS side. So AWS gives you supports for solving your technical issues, solving your pricing issues, or probably solving your security related issues. So these are recommended for big businesses, who has big client base, who use the account for a major volume of resources. But for us, we will go with the basic plan. That's all. You have to give information and choose the basic plan. And finally, they will ask you credit card information. So this is the myth that people generally think that, okay, if I give my credit card, will they deduct or will they do auto deduct? So there is no auto deduct happens. They want you to give the details of credit card just to check that you have a valid credit card, because people may lie, and if people lie and they generate a bill and they later on say that I don't have credit card. So that is why AWS is making sure that while creating account, you should share some credit card details so that they will get a guarantee that this person has a valid credit card with him or her. That's the only thing. They will not deduct anything from that. So this is the way you can create your account, and that is very easy and free of cost. I hope you understand. In case in future you want to create your own personal account, you can create from this particular process. So this is basic idea how to create AWS account. Now, what are the ways to access your AWS account? How can you log in into AWS account in different ways? The first way is management console. Second way is command line interface. And third way is software development kit, which is called as SDK. And command line interface is called as CLI. And management console is basically graphical user interface. So management console is actually a browser-based account login. Browser-based. I went to my browser and then I log in into the account. So this is called browser-based session management console, wherein you get all the access to AWS account resources with the help of graphical user interface. You can see the things here visually. You can use mouse to click on something, open something. You have these images, icons, links, buttons, symbols, everything you can simply use with the help of mouse. You can simply click on the service, open the service, create the resource. It is very, very simple interface. Suppose I go to S3 service. In S3 service, I can basically create a storage resource. So as a graphical user interface, I can click on that service name, click on create bucket. I can enter some name and I create one bucket. So what happened is I was able to use this account with the help of my mouse, with the help of these symbols and links here. This is called graphical user interface. It is called management console. This is one way you can access your AWS account. Second way is command line interface. CLI is something that you can relate to your command prompt. Basically, CLI is a way you can enter some commands to do those operations. For example, I created one bucket with the help of management console. But now I would like to do similar kind of operation or some another operation with the help of CLI. So what should I do for it? CLI is a way to do some operation in AWS account with the help of commands. And to know what are the commands available, first you need to have this thing with you. And I'm sharing you some important documents right now. Even you can Google like me, you will get the link also. You have to type AWS CLI reference v2. You can Google and type AWS CLI reference v2. So 2 means version 2. So this is version 2, the second page. And you can use this page also. This page is called as AWS CLI command reference. So you will be able to see multiple commands of AWS operations on different services. In order to understand the details of different commands, then you can see the list of AWS services under this command reference page, and they are alphabetically arranged. So whatever service you wish to perform operation on, and you don't know what is the command for that operation. For example, I go to DynamoDB service. So what is DynamoDB service? It is a database service. I can create a table inside it. So let us understand what are the operations available under DynamoDB. So these are the available commands under DynamoDB. You can see create table. This is also one command. There are a lot of commands available. Suppose I would like to do create table. So I'll go on create table. And then this is the page for create table command. Here you can see the complete description, synopsis, options, and then you can see certain examples also. For example, if you scroll down in the bottom, you can see the details of all the options available. Some examples are also given. See, these are some examples given. So let us understand create table. So this is the command for create table. You see that. To create a table with tags. This is one example given. AWS DynamoDB is the name of service, and then create table is the name of command. What are the details we are passing? Table name, music collection, and then we are giving some attributes. Okay. So this is the command that you can execute on your command prompt. In Windows laptop, there is command prompt. In Linux OS or Mac laptop, you can use terminal. So those who are on Linux and Mac, you guys can go open the terminal, and on that you can perform these commands in order to execute that operation. But the problem is, even if I have the knowledge of this command and everything, login is very important. How can anybody come and access my account? You have to log in into account, correct? Yes or no? So the first thing that you should know is, in order to log in onto management console, you have email ID password. Some user ID and passwords are given. On the same basis, for CLI, you require different set of credentials, which are called access key and secret access key. So these are two things, access key and secret access key. Access key and secret access key are credentials you can use for CLI, and the same credential you can use for SDK also. What are these credentials? They act as a user ID and password. They act as a user ID and password. So user ID and password are actually used for management console, but we cannot use user ID password for CLI and SDK. For that purpose, you require separate credential called as access key and secret access key. So the question is, if my manager gives me access key and secret access key, how can I log in through CLI? That's the question. So to log in from CLI, there are some prerequisite you need to do. So first thing that we will do right now is we will install AWS CLI software on our laptop. Okay, so let us go. You do one thing. First, you go to Google and then you type install AWS CLI. Only search for this keyword, install AWS CLI, and then click on first option. This is the documentation website of AWS where you can see all these details. So it is install or update to the latest version of AWS CLI. So what do you do now? First, so you need to scroll down and you can see all the three operating system options are there: Linux, Mac, and Windows. Now, what is the operating system in your laptop? You need to click on that option. So, for example, my laptop is having Windows operating system. So, I'll click on Windows. And once I click on Windows, then for Windows people, this is the first step: download and run MSI installer 64-bit. Okay, in this step, there is a link given, this one. You need to click on that link and it will download MSI installer on your laptop. I can show you. So if you click on this link, it will start downloading CLI v2.lsi on your laptop. You can see MSI software is downloaded on my laptop. I need to open that software and then start installing it. So I have to wait for few seconds because the setup wizard is preparing few data. So just wait for a few seconds until you get the next button. Okay, so I got the next button. I'll click on next, accept the terms condition, next, and install. So it will ask me few questions and then I should start installing it. So it is finished for me. So what you should do is, first of all, you should close the command prompt. Command prompt, terminal, whatever you have, close it and reopen it. Reopen your command prompt once again. Because if your command prompt is already open, then installation won't come. So I want you to reopen the command prompt. And you need to type now AWS --version. So what is the command I want to type? AWS space -- version. And press enter. So once I do that, I get version 2.16.4 Python 3.11.8 Windows 10 exe AMD 64. This is for Windows users. For Linux users, Linux will be written, but you can see CLI version 2.16 will be definitely there for everybody. We have successfully done installing AWS CLI. Now, without this, you cannot perform CLI operations. Remember. So first, you have to type this command, AWS space configure. AWS configure is the command to configure login details from the CLI option. So what you get after you type this command, what it is asking for? Access key. Suppose you enter your access key, then what it will ask next question? After you enter access key, it will ask secret access key. You understand? So this is the way you have to configure your CLI. And then after you log in successfully, you can easily perform commands. So I can show you if I can get some access key ID and secret access key. So in this lab, I'm going to see my own credentials. And let me first of all cross check if I can get my access key and secret access key. Okay, so yeah, I think we can create it. Okay, so do one thing, everybody. Do you have your AWS account open? Okay, so do one thing. On the top right corner, you can see your login details. In the sense that you can see your account ID, I am user, this particular option. Can you click on this one and you get the option of security credentials. Can you see this option, security credentials? Can you click on this? Then you come on this page, my security credential. You will be landed on this page, my security credential. By default, credentials are not generated. So we will generate our credentials right now. You can scroll down and find out this option, access keys. Access keys is the option they are providing you. So you need to click on create access key, and you can see, options like application running on AWS compute service, or local code, or command line interface. So go for first option, command line interface CLI, and click on next. First of all, I need to understand, and next. Here you don't need to type anything, just simply create access key. When you come on this page, please stop. Don't click on done. I again repeat, don't click on done button. You need to stop here. Are you on this page? Retrieve access keys. Don't click on done button, because after you click the done button, you will lose the access keys access. You cannot get the secret of that key. So before you lose anything, there is a download CSV file button there. If you click on download CSV file, then your details will be stored inside an Excel file. You can open it in Excel file. So you can just see, I got the details of access key, secret access key in my Excel file. I can color it also. You can see this is secret access key and this is secret access key. So I can copy this access key, go to my command prompt, enter it. Again, I can copy my secret access key, go to command prompt, enter it. Then it is asking me default region name. So you can see always in your account, default region is always, if you go, for example, to dashboard. By default, what is the region of AWS account? Northern Virginia, US East 1. Okay. So if you want to go to another region, you see the options. So right now it is asking you, do you want to go with the region Northern Virginia? Then keep it blank, or you can specify the region name. I'm keeping it blank because I'm happy with the default region name. And it is saying default output format. Are you okay? Enter. So basically you have to keep these two things blank only. And now you have configured access key and secret access key. So this is the way you are trying to log in into AWS account through CLI. Now we can perform operations. So first of all, what you do, you go to this command prompt, this management console, and open S3 service. You can search the service name in the search box also. Here also you can type S3 and you get S3 option. So first of all, everybody will come on S3 page and we will create one bucket. So I will do one operation from GUI and one operation from CLI. So I'm going to click on create bucket. So once I click on create bucket, only one thing I'll do, I'll give the bucket name. So here I can type anything. Make sure that bucket name should be small letter. If you give capital letter, it will give you error. So after you give the name, click on create bucket. And you can see the bucket is created on your screen. In my account, there are 2 buckets. In your site, it can be 1 bucket. Now we will do one more operation, but from CLI. What I'll type, AWS space S3 space LS. So basically ls is the command to list down the resources. So with this ls, you have S3 ls. It means it will list down S3 buckets. So you can see on management console, total there are 2 buckets in my account. So if I perform this ls operation, then I'll be getting details of both the buckets here. Can you observe this output here? You see this output? I'm getting details of both the bucket because ls is the operation used to perform list operation. Now what you do, first of all, you will type this. Okay. First of all, you have to type this AWS space S3 space MB space S3 colon slash slash, and there after slash slash you have to give bucket name. You can see the command AWS space S3 space MB space S3 colon slash slash. After slash slash you have to give some name. While giving the name, give a small letter. For example, I'm giving a name as Rajendra Wagh 123. So you can see my screen. AWS space S3 space S3 colon slash slash Rajendra Wagh 123. So this command will help me to create a new bucket with the name Rajendra Wagh 123. Okay, so I can click on enter and I get a response, make bucket is failed. So what it is saying that specified location consent is not valid. See, when you create a bucket, there is one constraint that you have to provide, and that constraint is region. You need to mention which region you would like to create the bucket. So I can do one thing. After this command, I can type space minus minus region space US dash east dash 1. So always make sure US dot east dot 1. So this is the region I have given. You can see the region name from here. For Northern Virginia, US dash east dash 1. So that region space US east 1 that I have mentioned. You can see the full command now. Only the name of bucket should be different. You cannot use the same name anywhere. Bucket name should be unique across the globe. So after this, you can check now the bucket must have been created. And you got a response, make bucket colon Rajendra Wagh 123. This is the proof that bucket is created. Just go back and see in the console, just refresh it. Now you can see the third bucket is being created. I can see it in the console also. Are you getting this? Something I'm doing it from CLI. I can do it the same thing from UI also. And after that command, it is being very clear that you can perform make bucket or this kind of any operation on any resource in AWS with the help of GUI options or with the help of CLIs. All right. So this is the way CLIs are used to access your AWS account. I'm sure you are very clear with this. Now the third way to access AWS account is software development kit. This is called as programmatic access. What is my programmatic access? Programmatic access is the access given to applications from the programs. So when you create one architecture, for example, this is for a website which you want to launch for photography. So your website is running on, let's say, EC2 server, and the photos are stored in S3 bucket. And the photographs are stored in S3 bucket. Then you are using RDS for database. In this architecture, your EC2 service will access S3 bucket and it will also access RDS for database operation. So when you see that when EC2 is accessing it, it means that from the website, these things will happen. Let's say upload of photo or download of photo. This is being, the logic will be written inside website code. Am I right? Same thing. When read and write operation happens on database, then that logic will be written inside the website code. Website is actually a programming code, right? So will they give access to S3 bucket and RDS machine for this website? By default, not, right? For that purpose, you should have SDK access. SDKs are software development kits for different programming language. So let's say Java. If your website or web application is made in Java, then you require Java SDK on this laptop. Or if your website is in Python, then you require Python SDK on your laptop. So whatever programming language you are using, based on that, SDK should be installed. They act as translator. And when from the program you would like to access AWS resources through the applications, then it is called as SDK access. So for SDK access also you require credential. And those credentials are nothing but access key and secret access key. You can use access key and secret access key for programmatic when applications you would like to give access to different services. Such as here, your website wants access to S3 bucket and RDS machine. So this is a Python code. This is a Python programming code to create a table in DynamoDB service. DynamoDB is a database service. So what resource we are creating inside it? We are creating table. So for creating table, this particular API operation is used, which is dynamodb.createTable. Under this, all these details are given. So what is happening? This is a programming code. This is my application. In that, this is a code which is in Python language. So in order to make this possible, we should be able to log in. It is simple. Website will be accessing your S3 bucket, DynamoDB table, many resources. So they will require access to those resources. And for that purpose, you should have programmatic access with the help of access key, secret access key. So to make these operations possible, third category of access is called as SDK access, which is called programmatic access. These are the three ways to access your AWS account. Management console, CLI, and a software development kit. Being a software developer, because you are learning developer associate, you should know all these three ways of accessing AWS resources. You should know SDK, you should know CLI, you should know management console. You can do some practice of CLI operations because I have shown you 2-3 demos for CLI. You have also practiced 1 or 2 demos. So you can do more practice at home on AWS CLI. I hope this is okay for you. We will start with a new service, identity and access management. And there are a few topics that we are going to cover. So this service, identity and access management, deals with access provision to your AWS resources in your account. So for example, I'll give you a simple explanation of what happens when you create an account. Let us consider this is a newly created AWS account by me. Every account gets account number also, which is 12-digit number. Okay. And when I create my own account, this is me. When you create the own account, so you are the owner of account, or you can say you are a creator of account. You can log in into account anytime with the help of email ID and password. You can log in. So the person with the help of email ID and password who can create the account, that is called as a root user. that email ID is the root user email ID. Root user is the owner of the account. He can or she can do anything in that account. They have full access. There is no restriction for them for any kind of access. But inside your company, there is no single person who is working on project. There are multiple people who works on project. For example, we have, let's say, Claudia, who is our developer. We have, for example, Anil, who is our database admin. We have Sudhir, who is our network engineer. Or let's say we have Fahad, who looks after administration. So these are the 4 people who are my team members who also work on the cloud project. So our client project has to be deployed on this account. So obviously, all these people will also require to log in into account in order to work on resources. They would also require access to the account. So what you would do, you would share root user email ID and password to them. In order to them to log in into account, you will share your email ID and password of root user. No, first thing, never share root user credential, because if any one of them gets the root user credential, they can get full control of account. They can change the password and later on you can never recover that account. Remember this. You can never reclaim the account. So for that purpose, in order to give them separate access, we have to create users for them. And we will use the service identity and access management. So in AWS, for that purpose, IAM service is used. So what I will do, I will create users in IAM service for these people. So this is the first user I created for Claudia, then for Anil, then for Sudhir, and then for Fahad. So once you create IAM users for them, everybody will get username and password. Everybody will have their own user ID and password. Simple. So if they get user ID and password, they can log in into account successfully. They can log in into AWS account with the help of their separate user ID and password. So root user credentials will never be compromised. But the question is, this way they can log in. So far we discuss about login only. Login refers to identity. So root user also log in. IAM users also log in. So this is referred to identity management. But I'm focusing on access management. So root user has full access. They can do anything in that account. But IAM user has no access or zero access. Every IAM user which is created, by default, they have zero access. It means even though Claudia, Anil, Sudhir, and Fahad, for these 4 employees, I have created IAM users, they cannot do anything in the account. They can log in. There is no doubt. They can easily log in into account, but they will have zero access to AWS resources. They cannot create any resource. They cannot see the resource. They cannot delete the resource. They cannot do any operation. So this is the way access management happens. So that is why the IAM service, when it gives the name, it gives identity and access management. Identity refers to login and access is referring to access. So this is also called as authentication and authorization respectively. Login, identity, they all indicates authentication. And access indicates authorization. So by default, every IAM user has no access to AWS resources. But this is not the way we should work. Actually, people should have some access. Fahad, Sudhir, Anil, and Claudia. These are 4 employees who are working in my team. Claudia is a software developer. Anil is a database admin. Sudhir is a network engineer. Fahad is a admin guy, administrator. What access should I give to them? I should give them access to the resources which are required by them. I cannot give all 350 services access. That if Claudia is a software developer, probably I can give S3, EC2, all these services to Claudia. Anil is a database admin, so I can give him access of RDS DynamoDB services. So there is a network engineer, so I can give him access of EC2, VPC, all these networking related part. Fahad is an administrator, so I should give him admin access. Admin access basically gives all access to AWS resources. So Fahad is someone who is admin guy. So generally I can give him access of IAM service. Why? Because Fahad should be able to create another users in future. This is Fahad's responsibility. Fahad is an admin person, admin of the account. So I will give him access of IAM service. This is called as principle of least privilege. And this is being recommended by AWS that you should follow principle of least privilege. It means always give minimum access whichever is possible. Never give over provisioned access. So if Claudia doesn't require access to VPC, then you should never give it to Claudia because that is not required by that employee. So if it is not required by that employee, don't give unnecessary permission. But how can you provide permission? For that purpose, you need to take help of document, which is called as policy document. So you need to attach policy to the employees. So I am attaching policy to Anil, Claudia, Sudhir, Fahad, everybody. And in that policy, I can write permissions. So in Claudia's policy, I'll write permission for S3 and EC2. For Anil, I will pass RDS and DynamoDB. For Sudhir, probably I will provide VPC. For Fahad, I will provide IAM service access. So this is the way the whole user management works in AWS. When you create account, you become root. But for other employees, you have to create IAM users. And to those IAM users, you have to provide policy document. This was the theory of this lecture. There are 3 topics of IAM service that we are going to cover: group, policy, and role. And then we will start with new service called EC2 as well as EBS. So as we have seen yesterday that identity and access management is a service who focuses on authentication and authorization, wherein we can create IAM users and we can attach policy to the IAM users. In that policy, we can write down permission. So this is the whole idea about permission management. So by default, every IAM user has no permission. To provide the permission, we have to attach the policy. Now we will take certain scenarios and let us understand the concept of group. Okay. So let us imagine I have a big team, and in that team, I have multiple employees having the same role. For example, these all employees are all developers. Then I have another employees who are database admin. There are few employees who are network engineer. For example, there are few employees, or there is one employee who is, for example, admin. So now I can see that this is a big team, and for a single role, for a single work, there are multiple employees working together. So I want to provide policy documents to them, right? So we have observed that for developers, we can attach policy which can give access to S3 service and Lambda service. But there is no single developer. There are 3 developers. So what I need to do, I need to attach the same policy to all the 3 developers. Same for database people, I need to attach policy. Let's say this is for DynamoDB. So both of them should have policy attached separately. Then for network engineers, for example, everybody requires access to VPC service. So you need to attach policy of VPC to all people. So this is the way it will work. But the problem is, if I can see, for the multiple people, I'm attaching same policy, right? Here, if you focus on developers, there are 3 developers. Need to attach policy to every developer. Same in case of network or database admin. So this is a kind of repetitive work. What we can do here is, instead of attaching policy separately to each developer, we can create a group of developers. So this is the concept of group. What we can do here is, instead of attaching policy to every developer separately, first you create a group of developers. You can call it as group developer. And in that group, all 3 employees, you can make it as member. And then whatever policy you wanted to give, that policy you should attach it to the group. Suppose S3 and lambda is written. So what is the result of this? The result is, if a policy is attached to the group, then that policy is inherited by all the group members. So this is Mr. A, B, and C. All 3 IAM users will inherit the same policy. In short, all 3 members will have the same permission, which are given by the group. Same thing you can do for database people. Don't attach policies separately. The best practice is to create a group, attach the policy to the group, and suppose this is your database group. Attach the policy which is commonly required to that group, and then suppose for database DynamoDB is a service they want. Same thing you can do for network engineers. For network engineers, create a group and then attach the policy for VPC. This is an efficient way of providing policy management. And now you can observe there is one guy admin who is a single person. So you can attach policy directly to him, or you can make him the member of a group. You can create an admin group and then you can attach policy to the admin group. Suppose it requires IAM access, whatever. So this is the way group mechanism works. I hope you understand this. So what I'll do, I'll show you practically how the groups are made. For that purpose, first I will go to IAM service. On this IAM dashboard, I will try to find out the left-hand side users and user groups thing. First, I need to have certain users. Right now, I'll create user for this demo. Suppose I'm creating one user called Rajendra. Okay, so this is the username Rajendra. I want to provide him management console access. I'm giving some custom password to him. I'm attaching him a policy. And create the user. Now it is not allowing me to attach the policy. No worries. But I have one user which I can show you. So what I'll do, I will try to show you group creation. So we have one person, one employee. Suppose I would like to create a group and add this person as a member. Then I will go to the left side user groups option. We'll click on create group. I can call it a group of, let's say, developers group. This is the name I'm giving. And then in that group, which users you want to add? I want to add Mr. Rajendra. And then what policy you would like to attach to the group? You can say this is group name. Here you are selecting members. And here you are selecting the policy which you want to attach to the group. So I can find, for example, S3 policy. And I'm saying create group. Okay. So it says that policy attachment is failed. But one thing I can show you that after you create group, for example, there is developers group here. If you can open these developer groups, you can see it is very simple. You will see the members, first of all. This is the member. You can add multiple members here by clicking on add users. And then you will see permissions. You can attach permission again from here. This is the way you can show that I can create multiple groups and can add members inside the group. So the effect of this is whatever policy you attach to the group, that same policy is applicable to all of its members. I hope this is clear. What I'll do a scenario. So for example, we have a group and to that group, we have attached a policy which has S3 and Lambda access. And now in that group, we have one person who already has some policy directly attached to him, which is about EC2. Then we have another person who has a policy attached to him, which is for SNS. And we have one more person who has no policy attached to him. What are their final permissions? Let's talk about the red person. What do you think? What permission red will have? So that is the group policy plus personal policy, which is directly attached. So directly attached policy gives him EC2 access. Group policy gives him S3 and Lambda. Second, the green person will have SNS, S3, Lambda. And the blue person, S3 and Lambda. Perfect. Okay. Now there is one more possibility that a person can be member of two groups. So suppose there are two groups. The first group, for example, group A, and the second group here. To the second group, we have attached group policy that gives him VPC access. And you can see there's a yellow guy who is a member of that group, which already has Lambda policy. But there is a red guy also who has EC2 policy. So group B has two members. One is the red person again, and the second is this orange guy. So red person's policy earlier was this. Now it should be changed. What are the updated permission of red person? Okay, the yellow will have Lambda and VPC. It is clear. What about the red guy? Red guy will have EC2, then S3, Lambda, and VPC. So this is the way group concept comes. Now we will go to the policy concept in very detail. So as we know that policy is a document which contains a JSON document which contains permission. So it is simply a document. And there is a language called JavaScript Object Notation, JSON. So you need to write in JSON permission And according to your configured permission, that policy gives permission to that particular person. So the question is, can a person have multiple policy attached to him? The answer is yes. A person can have many policy attached to him. There is no problem. Then can a person have group policy? So the answer is yes. The person can have group policy also. So how to write policy document? How to read policy document? What is the meaning of that? So if you want to see the architecture of any policy, first I would like to show you on the screen of this IAM dashboard. You can see policy section on the left side. In my account, there are 1200 policies available right now. If I can show you, these are the titles. Right? These blue colors are the titles of policies. And then there is very important thing, that is types. Suppose I filter and I find AWS managed policies. So these are the policies called as AWS managed. Let's say this one, I open it. AWS managed policy are read-only policies. It means that you can use that policy attached to the user, but you cannot modify that policy. There is no button where you can modify this policy, or you cannot delete this policy also. This is the system provided or AWS provided policy, which is completely managed by AWS. These are standard policies which are already created in your account. Because these are some standard requirements of every project, wherein they may require full access to a service or read-only access to a service. So these kind of things, it doesn't require you to create policy. They already have created certain policies for you. So let us understand CloudFront full access policy. First of all, this is AWS managed. So this is very simple. You cannot change it. And you can see the summary of permissions defined in the policy. What are the permission that policy gives and what level of access it gives, on what resources, it's all. So basically this is summary written in English language for our understanding. But if you click on JSON, then you can understand the policy is actually written like this in the JSON format. I can copy and show you in the notepad. Okay. Okay, this looks like this in the JSON format. So if you see the architecture of policy, you will find one important segment that is called statement. In policy document, you have to write down statements. It starts with the statement block from the square box, and you can find this is statement number 1. If you scroll down, this is statement number 2. If you scroll down, this is statement number 3. Statement number 4. So this policy has 4 statements. All right. All good so far? One policy document can have multiple statements. If you focus on one statement, let us say I'm taking the first statement and I will open it in another pad. So this is one statement I can show you on my screen. Every statement can have statement ID, which is called SID. SID stands for statement ID. Statement ID, you can give any alphanumeric number, alphanumeric word, or any pure alphabets, or maybe numbers. Whatever you want to write, you can write. This is for your own identification purpose. This is statement ID, which is purely optional. What is compulsory is these 3 things: action, effect, and resource. I repeat, action, effect, and resource. These are the 3 important things that you must know. If you understand these 3 things, then you can create multiple statements and create a policy document. So what does it mean? First of all, action indicates what operation you want to write down in the policy. So here the operation is list all my buckets of S3. So this is S3 operation. And which operation? Which operation? That is list buckets, right? So for list bucket operation, we are writing this statement. What we are doing? Are we allowing or denying? So this is the effect of permission. So do you want to allow permission to do this operation, or do you want to deny the person to do this operation? Deny means restrict someone. Allow means you are giving permission. You are giving permission to do list buckets operation. So I have written effect as allow. So action is list all my buckets. Effect is allow. So the person will be allowed to perform list bucket operation of S3. And the last is resource. On which resource? So here it is written as ARN AWS S3 star. What do you think? What does it mean? So it indicates all S3 buckets. Simple. All S3 buckets, right? Resources can define which bucket you would like to consider under this API. Let us do some example. Okay. So I'll do some changes. So statement ID is like example 1, 2, 3. Okay, now you need to focus what action I'm giving. Okay. So suppose I'm giving 2 actions. And I'm writing 2 statements. Okay. So let us understand the meaning of this document. First of all, how many statements it has? 2 statements, right? So let us understand first statement. Statement number 1 to 3. There are 2 actions given. First is list all my buckets, and the second is S3 get object. All my buckets and get object. And the effect is allow on all the buckets of S3. So what is the meaning of first statement? There are 2 operations, they are allowed. The second statement, action is put object. Put object means upload the objects. Upload the objects. So upload operation, is it allowed or denied? It is denied on all the buckets. So let me do one simple change in this. Okay. Let us try to understand this policy. The first statement, if you see, what is the action given? All actions of S3. S3 star means all actions of S3. All actions of S3. So all actions of S3 are allowed. So it is like full access of S3. The first statement indicates S3 full access, all operations of S3. But second statement, what it is doing? It is denying the upload. So ultimately, finally, combinedly, the whole policy document, what is the effect of this policy document? If I attach it to some IAM user, what will happen? Person can do all operation of S3 except put object. Can we take next example? Suppose I'm doing a change here and I'm writing down that upload is denied. This is the meaning of this statement. What are the permission the person has? Ultimately, the answer is no. So now I have this scenario. What is the combined effect of both the statements? Because the both statements are part of one policy document. So only download is allowed, but upload is denied. But I can see put object has conflict here. Here it is S3 put object allowed, and here S3 put object denied. Can you see that? Here S3 put object is allowed, and here S3 put object is denied. So when such a conflict comes, that the same operation will have allow plus deny both things into the same document, then we will not get any error, Basically, in that scenario, deny will get priority over allow. So what is the effect of this? Even though we have put object allowed, but because of put object denied, deny gets priority and put object operation finally will be denied. So what I'm doing right now, I'm keeping this policy document blank. This is a blank document, nothing is written. And this blank document is attached to a person. What do you think? What will be the effect of this? No permission. So I can write down that if in a document there is one situation that there are no statements written. So that is by default is deny. This kind of deny is called as implicit deny. Implicit means indirect. So if a statement is not written, then it is implicit deny category. Second, if allow statement is written, then it is called as explicit allow. Let us say I'm writing a statement where I'm allowing something. Explicit allow means you're writing allow statement is the only way you can give permission to someone. So here, as because of allow effect, person can do upload operation. The third category is you may find a statement where deny is written. This kind of deny is called as explicit deny. So let us add explicit deny statement here. So now in this document, there are three things available. First, does it has allow statement? What is the explicit allow statement? Get object or put object, right? Does it has explicit deny? Do you find deny statement here? Yes, we can find deny statement. That is get object. And do you have implicit deny? Apart from these two operations, forget about these two operations. Remaining operations are implicitly denied. Is there any statement for list bucket? Is there any statement for EC2 full access? Is there any statement for Lambda read-only access? So you imagine about all the remaining operations which we have not mentioned, which we have not explicitly written. In this document, only two operations are written. One is put object, second is get object. But what about remaining operations of S3 service? Also, all operation of all other services, they are not written here. If I ask you, can this person view or can this person list EC2 instances? Can this person list EC2 instances? The answer is no. Why? Because that statement is not written in this document. If it is not written, then it is implicitly denied. Implicit deny is always there. We wanted to deny get objects. So instead of writing deny statement, I could have make that statement not written. This way, if I remove this statement, still get object is denied. Get object operation is still denied because it is implicitly. So if you want to deny something simple, do not write statement. So it gets denied automatically. But still I have written the deny statement. Why? Why people write explicit deny? Because by default, implicit deny, if you do not write statement, implicit deny is always applicable. But still, why people prefer to go in certain situation, go for explicit deny? Because I'll give you a simple example. Let us say this is the person and I have attached a policy which allows him what operation? I think as per my document, what it is allowing him, put object. Okay, so put object is allowed. And we are very happy because the person can do only put object. But if your manager says this IAM user should never ever be able to download the files. So compulsory, he should never be able to download the file. So you can say that, sir, I have not written the statement for download get object. So obviously he cannot do it. But there is a chance that in future we may attach another document to him, or he can become member of a group. And in the member of the group, we may have a group policy attached to him. Suppose the group policy gives S3 star full access. So if the group policy gives full access, then he can do get object also. Accidentally, he got full access because of the group policy. So your manager was saying, Sudhir, what happened? Sudhir said that, so it was not my mistake. Because of the group policy, he got full access of S3, and because of that, he can do get object. But then manager will be, no, Sudhir, you should learn how to give explicit deny. What is that? You should explicitly deny that operation here. Suppose you have explicitly denied now. Now what happens, even if you get group policy or another policy allowing him the same operation, still deny will win over allow. So even though the IAM user gets another permission or gets another policy, because of which he gets the permission, still he cannot do get object, because get object is explicitly denied here, and deny always gets priority over allow. So this person will never ever be able to download the objects from the bucket. So let us proceed with the roles part, which is called IAM roles. So role is basically a way to give temporary access to AWS resources. So what is this? This is also permission management, but this is regarding providing temporary access to AWS resources. So let us understand with one example. Suppose we have an IAM user, Anil. Anil is my IAM user. And generally he perform operation over S3. So we have given him S3 full access. As per his responsibility, he has to work on S3 service. So we have given him S3 full access. But it sometimes happens that, Anil may have to work on some different service temporarily. Temporarily means just for short duration. It may be in the same account or different account. Suppose Anil belongs to account number A, AWS account I'm talking about. And this may happen that there is one more account of company, which is account B, and we need a help of Anil to perform operation on, let's say, DynamoDB service of account B. So there is one DynamoDB service, DynamoDB table, and we need to take help of Anil to work on that service. So in that scenario, the first question, working on DynamoDB, is it Anil's regular job? No, right? So if he wants access to DynamoDB, what should we do? We should create roles. Role will give temporary access because this is not regular job. So as per the principle of least privilege, you should give temporary access. So what is temporary access? Is that we can create a role inside account B. Okay. We can attach DynamoDB permission to that role. And then we can add session duration. For example, 1 hour. So we created a role. We attach a policy DynamoDB and we have given some time, 1 hour. And then Anil can assume this role. What will happen? Anil will be able to access DynamoDB service of account B. But for how much duration? Only 1 hour. How much duration he will be able to access? What is the session duration I have given? 1 hour. So one single session will be of maximum 1 hour. After 1 hour, he cannot use that DynamoDB service in that single session. So this is a way you can give temporary access to users to access services. And this example is famously called as cross-account access. So to get cross-account access, assume role, operation is performed by the user and they can assume the roles of another account. Can we have roles inside the same account? That is also possible. That is called same account access. It means there is only one account and account A. So I'm talking about same account access. So you know that Anil is a member of account A, is a user of account A. We have given him S3 full access. That's all good. And we want him to access DynamoDB service of the same account. So again, what we will do, we will create a role. We will attach the DynamoDB policy to him. And then we will give session duration, let's say 2 hours. So what Anil has to do? Anil has to perform one operation called as assume role. So he will assume the role, and the moment he assumes the role, his session will start. So for how much duration he has access to DynamoDB, it depends on session duration. So he can access DynamoDB for 2 hours continuously. After 2 hours, session will be expired. So this is the way we can control that the person is able to access the service for only temporary duration. Imagine we are talking about S3 access. Okay, suppose you want to give get object. This is the operation I want to allow. So imagine Ashdev, there are many buckets in my account. For example, there are 3 buckets in my account. So bucket is actually a resource of S3. Every bucket will have its ARN. ARN is the unique identification of your resource, not only buckets, but EC2 machines or Lambda function. Every resource in AWS has its own ARN. ARN stands for Amazon Resource Name. So when you make a policy, you have written effect as allow, you have written permission of operation as S3 get object, but you have to also tell which bucket you want to make it applicable. So do you want person to do download object on all the buckets or specific bucket? Suppose you want to allow it for all the buckets. That is why you write S3 star in the resources. If you see the ARN here, what is the ARN? ARN AWS colon S3, after that star. So this is the way whatever buckets are there in your account, in fact, whatever future buckets will also be created. Then that person will be able to access all the buckets and he will be able to download all the objects of all the buckets. But instead of that, if you specify a single bucket ARN, let me show you how does it looks. Suppose I go to S3 service and let me create a bucket for you and I can show you the ARN of individual bucket, how does it looks. And S3 is just for example, otherwise ARN is applicable for all the resources. So for you, I have created one bucket. Let us open it and try to find the properties. So this is the ARN of the bucket. What is the ARN? I can show you. So the format of ARN is ARN colon AWS colon S3 3 times colon. And then finally you write bucket name. So this is the bucket name I have given. So what does it mean? The first statement, person can do put object. He is allowed to do put object. But on which bucket? The bucket which I have mentioned here. This is an individual bucket ARN. But if instead of this, if I write star, then it seems that he can he can upload object of all the buckets. Or if I do this, then he can upload objects into only this bucket. This is called resource field. So if I want for a specific set of buckets. So when you want specific set of buckets, it means you want only 2 buckets out of all buckets, only 3 buckets you want to allow. So you can give ARN by giving comma for all 3 buckets. Or you can attach tags. You know, tag is something that you can attach to any resource. And with condition, you can mention that here you can write a star. But in the next line, you can write condition where you can see that if the tag is matching this, only then, otherwise not. So I think we can go back to the role concept. So what I'm going to do, I'm going to show you a demo of role. I don't have two accounts, so I cannot show you cross account access, but I can show you same account access. And that purpose, we will take same example of Anil, and I will draw a new diagram for your understanding. So Anil is an IAM user that I'm going to create. So he is an IAM user. So in the step 1, we will create an IAM user Anil, and we will attach a policy to him, which is S3 full access. Allow S3 full access. This is the policy I'm going to attach. Then I'll create a role in the same account, and to the role I will attach DynamoDB policy, DynamoDB full access, and I will give session duration. Session duration I can give for 2 hours. Right? This is step number 2. And finally, in step number 3, Anil will try to assume the role. Assume role is an operation that Anil has to perform. After assume role, he can use the DynamoDB service. And this is what we are going to do practically. So number 1, create a user Anil, attach him S3 full access. So in this account, I'm going for IAM service. I'm a root user of this account basically. There is nothing written, only account number is written. So this is a root user. So the root user is creating one IAM user in his account. Suppose I'm creating Anil here. And A is capital, you can remember. So to Anil, I'm giving a custom password. For example, one password I'm giving to Anil. Next, I'm going to attach S3 policy to him, which will give him permanent access to S3. And I'll create the user. So I can do a separate login of Anil here. So this is the login of Anil. Let us try to go to Northern Virginia region. And now Anil has logged in into the same account. What access he has right now? S3 full access. So he can access only S3 service. My question is, can he access DynamoDB right now? Let us check. Let us check whether Anil can access DynamoDB right now. So we know that he cannot access, but I would like to show you. So he's trying to create a table inside DynamoDB and he gets an error. He says that the user Anil is not authorized to perform DynamoDB create table. Simple. He is not authorized to perform DynamoDB create table. So what I'll do now, I'm coming back. I'm an root user here. So what I'll do, I'll go to roles and I'll create a role for Anil. Let us create it. So the first question they ask me, what is the trusted entity? In this example, you have to take second option, that is AWS account. You have to choose second option, that is AWS account. So I'm going to choose second option, AWS account, and they are asking me whether the user belongs to same account or another account. So they are asking me about Anil. So the person for whom you are creating role, is he belong to same account or another account? So if I say another account, then I have to give account ID. So this is the way cross account access can be possible. Are you getting my point? Imagine Anil belongs to some different account. Okay. And you are creating role in this account. So obviously you have to provide account number of Anil. That will be called as cross account. But we know that Anil belongs to same account. So I can say this account only. You can take same account number. And then they will simply add permission. So this permission will be added to the role. You understand? We are creating a role here. So add permission is going to add permission to the role. So from the diagram, can you tell me that what permission we would like to add to the role? Obviously, DynamoDB full access. So let us go and try to search for DynamoDB full access. I have attached it. Now they are asking me role name. So I can say that this is role for Anil. I can give any name, but for your understanding, I'm calling role for Anil and create it. So my role is created. I can show you the role here. This is role for Anil. It is the name of the role. And the permission is DynamoDB full access. And here you can see session duration. So by default, what is the session duration? By default, the session duration is 1 hour. You can go to edit button and you can change the duration from 1 hour to 12 hours. You can have standard times such as 1 hour, 2 hours, 4 hours, 8 hours, 12 hours, or you can give custom duration in terms of seconds. But minimum and maximum is always 1 to 12 hours. You can give any duration between 1 to 12 hours. So right now, I would like to give 2 hours as my session duration. So one single session of Anil will be maximum of 2 hours and save it. So can you see, I have configured the session duration. I have configured the session duration. Role for Anil, session duration 2 hours. Permission is DynamoDB full access. So I have finished second step, right? I have finished step number 1 and step number 2 both. However, there is one thing that you need to do additionally, is that you are creating a role for a person. But Anil is not the only user in your account. There can be another users also. They can also assume the role. So how can you make sure that only Anil will be able to access? Because assume role has to be done by Anil only. That you have to control somewhere. So for that purpose, there is one more thing you have to do in the role. There is a concept of trust policy. And every role has a trust policy. Trust policy is a different policy. This is the permission policy. This DynamoDB is giving permission. Trust policy is a different thing. In the trust policy, we can mention who can assume role. It tells you that who can assume this role. You can mention that inside this policy. I can show you. So this is role for Anil. This is the permission policy, which is DynamoDB. And just beside it, there is trust relationship, where trust entities are mentioned. So if you edit it, you can see that right now, STS assume role is allowed. Who can perform assume role of this role right now? Who can do it? Root can do it. We should change this ARN. Instead of root ARN, what we are writing, what we should write? We should write Anil's ARN. So what is the ARN of Anil user? I can show you how to find out ARN of a user. So first of all, you have to go to IAM service, open that user Anil. So try to find Anil inside the user list and open the page for Anil. So this is Anil user and this is the ARN of Anil. So you can copy the ARN of Anil and just paste it here. Now can you see I have changed the ARN? Who can assume the role? Anil can assume the role. Is that clear? So let us update the policy. Now Anil can assume the role. So your step 2 is done. Step 1, step 2, both are done. Okay, so finally we will do step 3. And now in step 3, I can show you how Anil can use this role. Okay, now I can show you how Anil can assume the role. So let's go to Anil side. So you can see this is Mr. Anil who has logged in into the same account. And now Anil is not able to perform create table. So now what I will do, I will ask Anil to assume the role. I will share him role name and everything. So what Anil will do, please focus. Anil will first of all go and click on this particular option where he can see account number and IAM username. And you can see beside sign out button, there is a button called as switch role. Can you see this? I'm moving my mouse. Can you see switch role button? Where did I get it? On the top right corner where you can see your details of login. So you need to click on switch role. So Anil will click on switch role button. And once you do it, a new page will become, which is switch role page. Here, you have to give details of role, not details of Anil. Anil's details already are there. They're asking you details of role. So the first question, role belongs to which account? So I can identify the role. This is the role, right? What is the account number wherein a role is there? This is the account number. So let us copy paste. What is the name of role? So name of role is role for Anil, copy paste. These are the two compulsory details required. Account number of the role and name of the role. Is this clear? Now optionally, you can give display name. Suppose I'm calling it as funny role. Just a display name I would like to show you. Display name is the name that will be shown. And display color, suppose I'm choosing red color. And click on switch role. And the moment I click on switch role, my 2 hours are started. On the right side, you can see display name is funny role in red color. And it is saying that currently active as role for Anil. Do you see this change? Basically, Anil has signed in as IAM user Anil, but right now currently he is active as role for Anil. And his 2 hours are already started because session duration is 2 hours. And now he would be able to perform DynamoDB. You can see. Let us create a table for Anil. So Anil is trying to create a table. Table name is not. Can you see he has successfully created a table? Did he get any error? No error. Because he got an access to DynamoDB through the role. He is currently in funny role, which is role for Anil. And his 2 hours session is still going on. So he can do operation inside DynamoDB. After 2 hours, what will happen? Permissions will be revoked. He will lose the access to DynamoDB because role session is expired. But whatever he created, will it be there or not there? Suppose he created this table now, right now. So after 2 hours, whether this table will be there? Of course, yes, because role decides access. It doesn't decide resource deletion or creation. Only access will be removed. But whatever you have created, that will be remain there. So this particular table will be still there even though the access is removed. For example, let us do it right now. Anil will switch back. You see the switch back button? Because of switch back, he can leave the role right now. So now he clicked on switch back and he has voluntarily left the role. And then you can see it says that you are not authorized to see the table list. Before switching back, he was able to see the tables, but now he is not able to see the table because he has switched back from the role. So he voluntarily has left the role, even though 2 hours are still remain, but he has left it because he says that, sir, my job is over. I don't want to continue with this role. So he has left it. But does this mean that the table are deleted? The table created by him, are they deleted or not deleted? Not deleted. I can show you. From the root users login, I can show you DynamoDB tables created by him are still there. Only his access is removed. See, this was the table made by Anil. And even if Anil wants, he can assume the role again. Go here, again click on funny role. And he gets the access back. New session is started. You can see he got the access to DynamoDB. He can again left the role. He lose the access to DynamoDB. So he can create as many sessions as he wants. Again, he clicks on funny role. He gets entered into the role. So every time a new session is created. Imagine if this is cross account access, then Anil can access a service of another account also. So this is what I taught you, and this is called as user role. Role has multiple types. Whatever I have taught you was a user role. User role are the roles who can be assumed by users. And whatever I have shown you is the user role example. And when you create a user role, that time you can go to IAM service and I can show you right now. When you go to user role, that time, how to decide whether it is a user role or not, you have to choose second option. If you want to create role for users, if you want users to assume the role, then choose the second option. Okay. If you are creating role for an IAM user, then go with the second option. Now, I will also tell you what are the other types of role. This was just user role. Second is called as service role. So what do you mean by service role? So basically service role is the role that can be assumed by AWS service. Simple. User role is a role that can be assumed by IAM user. Service role is the role that can be assumed by service. So you'll be like, sir, why services required to assume the role? So the answer is, in AWS, if one service wants to perform operation over another service, suppose inside your architecture, there is one EC2 server who would like to do some operation on S3. So this is called as service to service communication. So this is service to service communication. So for EC2 to perform operation on S3, does it require permission? The answer is yes. In AWS, whether you are a user or you are a service, I'm showing you both the scenario. This is the example of service, this is example of user. For user, permissions are required. Permissions can be given by policy or with the help of role. So user can assume role or user can see his policy and he can access the bucket. But what about EC2 service? How a service can access another resource? For that purpose, service roles are required. So even services requires permission to perform operation over another services. So generally compute services would require roles. So I'm taking example of EC2. So in this example, EC2 requires permission to perform operation over S3. So what I will do, I will create a service role for EC2 and attach S3 permission. Simple. So step 1 is create a service role, attach the permission, and step 2 is add the role to EC2 machine. So I'm creating a role for EC2. So that time, what is the trusted entity type? You will take first option. Okay. You will take first option, which is AWS service. So you are creating role for service. So that is why AWS service is the option. That AWS service you will choose only if you are creating service role. An AWS account you will choose only if you are creating user role. So right now I'm creating service role and I'm choosing the name of the service who would like to perform the operation. So that is the service role for EC2. Next. Now we will attach permission. What permission I should attach to the role in this example? S3 full access, right? Because we have taken S3 service. So EC2 wants to perform operation over S3. That is why S3 full access I am giving. Next. What is the name of the role? I can say that sample role for EC2 to S3. This is for my understanding. I have given the name. And in the trusted entity, who is the principal here? A principal is a service. What service? Basically, principal is EC2 service. So you don't need to give ARN of EC2 because service role are generic. They are created for all the resources of that service. Unlike the user roles, service roles are generic. Suppose you are creating a role for EC2, that will be for all the EC2. Any EC2 can assume it. That is why we have given the name. We don't need to change it. It's already there. So we will not change the trusted policy. You can see sample role for EC2 to S3, and it has S3 full access, and trust relationship, we will be happy with EC2. And we have nothing to do with session duration. 1 hour is enough. If that expires, EC2 will again assume the role. So no problem. So what is the scenario is I have created a role for EC2 machine. Then the question is, how can I add this role to EC2? Step number 2. How to add this role to EC2? So basically for adding the role, you should create one machine. And this is not required. You should create a machine. So I'll go to EC2 service and I'll create a EC2 server for you. Okay, so let us create one EC2 machine for you. So suppose you're creating one EC2 machine. So one machine I have created. Imagine your machine is ready and you want to modify the role. You want to add the role to that machine. How to do that? So first of all, I'll wait for completion of that machine, and then if it goes to running state, then I'll show you how to modify the role. But before I add the role, I would like to show you whether this EC2 can perform operation over S3. Okay, so my machine is running. I can show you that this EC2 machine cannot perform operation on S3 without the role. So I can first of all show you that whether this EC2 can perform operation on S3. So that is why we have logged in inside the EC2 machine, and we will try to perform an operation AWS S3 LS. So I'm trying to perform list operation on, I would like to list all the buckets inside S3 service. What you get? You get credential error. They are saying that this EC2 machine cannot log in into this EC2 machine cannot access S3 service, right? So what I'll do now, I'll go back to my EC2 service, go to actions. Please see what I'm doing. Go to actions, security, and this. You can take a screenshot. What are the options I'm selecting? First, I have selected the machine. Second, I went on actions, click on security, and the last option, modify IAM. So when I do this, I can find out the IAM role. So the name was sample role for EC2 to S3. You can see I have selected the role which I created and update it. So now once I update the role here, you can see successfully attached sample role to the instance. I will try to do the same thing. AWS S3 LS. And I got bucket, all the bucket list in my particular S3 service. What I will do, I will try to perform AWS S3 LS operation. And we got an error. So they are saying that from the EC2, you cannot access S3 because the credentials are not, they are trying to find credential, but the credentials are not there. What they are saying, unable to locate credential. They cannot find the credential of S3 because when you get the role, you get separate credential. So EC2 doesn't have role. So EC2 does not have the credential to find S3. When you assume the role, you get separate credential. This was applicable for Anil also in the previous demo. Here also EC2, if it assumes the role, it gets particular credential. Right now, the system is not able to find those credentials. Now what I will do, I will add the role. Select the machine, go on action, click on security. You can take a screenshot of this, Claudia Beckman. Can you take a screenshot of this image? Once you click on modify IAM role, you need to just find out the role which you would like to attach. So I'm attaching sample role for EC2 and update the role. What happens? Because of these roles, EC2 will get credentials. Temporary credential for credential is not attached, role is attached, but what it does, I'll tell you. When EC2 will try to assume the role, there is an STS service which will give temporary credential. And those credential will be used to access S3. So now EC2 is trying to assume the role, because when it performs the operation, it will assume the role. Immediately it gets the thing. So do you understand two types of role? User role, service role. Okay. So that is all about role. Now there is a third type of role also, which is called role for federation. But this is now deprecated. I can show you. People can create third type of role, which is role for federation. Suppose if I create the role. For role for federation, number 3 and number 4 options are there. What does it mean? You can allow the people outside the account to log in and get access to your resources. It means that if you go with third option, then you get identity provider, Amazon, Cognito, Facebook, Google. So even though the person is not member of AWS account, he is not an IAM user. He is some outsider. He is not IAM user of your account. So that person can access your resources with the help of Amazon identification or Cognito login, Facebook login, or Google login. That's called web identity. So this allows federated user by specified external web identity to provide. So let's say I say Google. Then there are some settings that you need to find out. But the point is, people using their web identity can access your AWS resources, even though they are not member of that particular account. Then fourth option is also federation, but this time it is not web identity, it is SAML 2.0 federation. It means SAML 2.0 is a standard that is used to connect your corporate directory to your AWS account. So what does it mean? Do you know companies maintain their corporate directories? Maybe Okta or Microsoft Active Directory, or they may be having their own solution where you are the user of that login. You always log in into your portal, right? Every day morning, you go and you log in into your portal. So you are the user of that corporate directory. So if you want people like that to access your AWS resource, you can do with SAML 2.0 federation. So web identity and SAML 2.0 are the examples of federated role, which is third type of role. But from last 2-3 years, AWS has deprecated this method. They say that don't use this method. Instead of that, what they did, they created a new service called as Cognito, which we are going to learn definitely in the last lectures. In Cognito service, you can do federation better. So when I will teach you Cognito, that time I will teach you federation part. So there is no need to learn federation in IAM service. We will do federation using Cognito, which is a recommended way. So that's now the end of IAM service. We discuss about group, we discuss about roles, we discuss about policies in very detail. Okay, so now we are going to start with a new service called next service called EC2. EC2 stands for Elastic Compute Cloud. What is this service? This service is a compute service which gives us virtual servers inside AWS. It means that it can give you a virtual machine. On that virtual machine, you can deploy your application. It is a virtual machine where you can deploy your application. An application can run on this EC2 machine. So this is something which comes with different capacity. I will discuss about that. How to create one EC2 machine, how to deploy application. There are many demos that we are going to perform. Okay. So the first thing that I will start with is I'll teach you how to create EC2 machine, which is called as EC2 instance. How to create EC2 instance. And this will help you to understand architecture of EC2. So basically the EC2 machine is a compute resource. So this is my EC2 instance. One instance indicate one machine. So this is one instance. Now similar to your hardware server. So if you compare, let's take example of a laptop, which is also a hardware machine. So for a hardware machine, what are the things very important? First is operating system. Second, CPU. Then memory, random access memory. Then storage. And finally, application. So you're talking about softwares. Am I correct? These are the things very important for a laptop or for any hardware server. So same thing we will need for EC2 also. What we will need? First of all, for any EC2 machine, we require operating system. So for EC2 to get operating system, we have to use images. So what file is used to install operating system? Image file is used, right? Let's say for Windows, we use ISO files to install operating system on your laptop. Similarly, for your EC2 machine, we require image, which is called as Amazon machine image. So EC2 also requires OS, which is given by AMI. These AMIs are available into your account, and these are available for all the operating systems, Windows, Linux, Macintosh, and in all three operating systems, all their versions, they all are supported by these AMIs. Second, EC2 machine also requires CPU and memory capacity. For the purpose of these two, there is a concept called as instance type. What is this instance type? Instance type decides CPU and memory combination. So AWS has created more than 750 instance types, and these instance types has multiple combination of CPU and memory. While doing the practical, we will observe different instance types. So the solution to second and third requirement is we can choose instance type where we get a method or a mechanism to choose your CPU and memory. The next thing is storage. So in your laptop, you have hard disk or SSD, solid state drive, inside your laptop as a storage device. So similarly for EC2, you require a storage device. Basically, why the storage is required? Why do we need storage device into your laptop? Why do you have hard disk or SSD in your laptop? The important purpose is to store OS and application. Where the OS and application, when you install OS and when you install software, the files are in storage devices, right? These storage are primarily used to store operating system and application files. And then you can store other type of data also. So similarly, EC2 system also requires a storage so that it can store operating system and application files. And that storage is given by another service called as EBS. And it is called as EBS volume. So what is meant by EBS? EBS is a separate storage service, which is not part of EC2. EBS is a different service. And what we can do in EBS, we can create storage volumes. So let's say this is the volume of 8 GB. So EBS is a block level storage device who is made with the help of underlying technology like hard disk or SSD. There are different types of EBS we are going to see, but you can choose whether you want hard disk type or SSD types. Accordingly, you can create an EBS volume, and that EBS volume will act as a storage device for EC2. So as I told you that these are two separate devices. One is EC2 instance and second is EBS volume. But then how they are connected? They are connected through network. And now this becomes a compute machine. EC2 instance is a compute part, EBS volume is a storage part. And they are connected through network. That is why EBS is also called as network drive. So when you install OS using AMI, that OS is actually stored inside EBS volume. The files of OS are stored inside EBS. And if you install or if you deploy any application, the application files are also stored inside EBS. So when you start the machine, where is the OS boot from? OS will boot from EBS volume. Okay, so AMI, instance type, and EBS volume are the options that we are going with. Finally, the last question is, how will you install the applications? How will you deploy the application on single EC2 machine? So for that purpose, you have two ways. For application installment, you have two ways. Number one is called as user data script. And number two is called as remote login. And I'm going to show you both the methods. We all will do the practical of both the methods. Okay. First, I will show you how to install application using user data script. And second, I will show you how to do installation of application while doing remote login. So what is the difference between them? The difference is that the first method is a bootstrapping method. It means it allows you to install the app, install application at the time of launching the machine. So when you create the machine, it is called launching process. When you launch the EC2 machine, that time this data script will run and it will install application. And the second method is it can allow you to install application after the launching of EC2. Suppose you already have launched one EC2 which is already running. And after that you want to install something on EC2, then you should know remote login. User data script and remote login. That the first method will allow us to install the application at the time of launching. And the second will allow us to install the application after the launching of EC2. And we are going to do both the demos. All right. So for creating EC2, these many details are required. Then the second question is, what else is required for launching EC2 machine? So the prerequisite for that is network. Inside your AWS account, we should have one network inside your AWS account. So for that purpose, we have a service called VPC. So what will happen? While launching the EC2, they will ask you network settings. Network settings means they will ask you in which network. For example, this is one network, okay, which is called VPC. In which network you would like to launch your EC2 machine. So you can tell that I would like to use this network. So that is decided by VPC. So right now, you don't have any idea about VPC service. You don't know anything about networking because that is a future lecture. So right now, what we are going to do, we are going to use default VPC. So there is one default network already available, which is called default VPC. This default VPC will help us to choose the region for our EC2. Do you remember region and availability zone? So we can decide which region you would like to launch your EC2. And there is one more concept called as subnet. Subnet will help you to choose the availability zone. So you can decide which region and which availability zone I would like to launch my EC2 machine. So that is called network setting. Right now, we will go with default VPC and default subnet, which are already available in your account. So we are not going to create any VPC or we are not going to create any network for our EC2. We are going to use the default network and default subnets. But so we will go step by step. So right now, whatever things I have written at the top, OS, CPU, memory, storage, application, they are required. You can configure them. But when they will ask you about network operations or network configuration, you will go with default VPC and default subnet so that you can choose region and availability zone. How your EC2 will look like, I can show you in another diagram. So your EC2 will look like this. You will choose default VPC. Inside that, you will choose default subnet. any one subnet. For example, you have chosen default VPC of Northern Virginia. This is the region you have decided. And then you are choosing subnet, which is in availability zone A. So you have decided Northern Virginia AZA. Inside that, your EC2 will be launched along with your EBS. So this is the networking scenario. Then we all will be sitting here inside public internet. So we all are connected through public internet. So if you want to access the application on EC2, suppose I'm launching some website. If I want to access the website from public internet, what do I require? How can I access website running on EC2? In my browser, what should I type? Public IP. Public IP is required. So we'll get public IP and we will try to test whether we can visit the website. You should know the whole idea about the placement of EC2 inside network and how from the public internet we can test the website. First thing that you have to do is that, so let us go and search for the service EC2. EC2. Let us search for EC2 service. The tagline says virtual servers in the cloud. Open this EC2 service. So this is called EC2 dashboard page. The first thing you should understand that you can see different option on the left side. You can observe my screen. First is instances group. Second is images group. Third is EBS group, which is Elastic Block Store. Next is network and security group. Next is load balancing and auto scaling. So EC2 provides these many features to us. Out of that, today we are going to create our own EC2 machine. Okay. For that purpose, you have to click on left side instances option. Under instances, you have first option called instances. You have to click on instances option. And you can see right now, there is one machine available in my account, but that is already terminated. But in your case, it will be 0 machines, right? 0 instances are there. Now what we will do, we will go and we will click on launch instance. There is an orange color button, launch instance. Here, first question is name and tags. You can attach tags to your EC2 machine. So name is the default tag. If you want, you can give any name. For example, I'm calling it as demo machine. Okay. You can give any name to the machine as per your choice. This will be the name tag. Next is, if I just show you all the options here. So EC2 has these many options. First of all, application and OS, that is AMI. Next is instance type. Next is key pair, network settings, configure storage, and advanced details. So we are going to give all the values for all these options, right? So let us start with the first, application and OS images. When you see application and OS images, so you will get list of AMIs. If you want to see all the AMIs, then you get a button here, browse more AMI. Can you find this blue color? Browse more AMIs. You see here on my mouse. You can click on browse more AMIs and you will find that there are 47 AMIs available by AWS. 47. Suppose the first is Linux, second is Linux 2, third is Mac Sonoma, fourth is Mac Ventura, next is Red Hat Linux, next is Mac Monterey, next is Red Hat Linux, next is SUSE Linux, then Ubuntu, then Windows Server. See, you can see all the options are there. So in these options, we are going to choose first AMI, that is Amazon Linux 2023. Why? Because this AMI is free tier eligible. It means that you can get free tier quota for this AMI. So you will not get much billing on it. So I have to click on select. So you can see my screen. Amazon machine image is Linux AMI that we have selected. So if it is done, then we will go with the next option, that is instance types. Under the instance types, you can click on compare instance types. This is blue color option. Compare instance types. So when you click on compare instance types, I can see more than 780 instance types are available. More than 780 instances are available. So let us understand the meaning of it. Let's say the current selection is T2.micro. T2.micro gives me 1 CPU, 1 GB of RAM. Let's go to another instance type, T3.micro. T3.micro gives me 2 CPU and 1 GB of RAM. Let's go with C3.large. C3.large gives me 2 CPU and 3.75 GB of RAM. Let's go with C5.xlarge. This instance gives me 4 CPU and 8 GB of RAM. We can get a combination of CPU and memory capacity. Let's go with the last option in this first page, that is C5a.24xlarge. This instance type, if we choose, then our EC2 will become 96 CPU and 192 GB of RAM capacity. Even you can go to next pages. Let's find out this one. C6gd.xlarge. It gives me 4 CPU, 8 GB of RAM. Let's go with the some different page randomly. Let us find out last option here. M5ad.xlarge. This gives me 32 CPU and 128 GB of memory. Let's go with the next page. This one. M7i.metal 48XL gives me 192 CPU, 768 GB of RAM. So what is happening is you can choose different instance types and accordingly you get the different combination of CPU and memory. And your pricing of EC2 depends on instance types as well as AMI. So for free tier quota, in order not to get billed, we will go with T2.micro for our demo, which has 1 CPU and 1 GB of RAM. Shall we proceed now with T2.micro? You can see my choice is T2.micro and I'm going to proceed with the next step. The next step is key pair, where login is written. So why this option is given, what it will do for us, what this key pair means. This key pair is required for remote login. If you remember, for application installation, there are two options. You can go with user data script or you can do remote login. So whenever you want to do remote login, you should create a key pair for you. So in my first demo, it is not required. So what I will do, I will go with proceed without a key pair. What option I will choose? Proceed without a key pair. Because in my first demo, I do not require a key pair. So proceed without a key pair. That is my key pair option. Next question is network setting. In network setting, you can find out there is a network already selected. Which one it is? Default VPC. Can you check, is it default VPC? So which region we are in right now? Northern Virginia. So where is our EC2 will be launched? Our EC2 will be launched in Northern Virginia region, right? Second, subnet. What is written in subnet? No preference. It means they will choose any subnet in any availability zone. Are you okay if they choose any availability zone? Yes. If you are not, then you can click on edit button and you can choose the subnet. Suppose I'm choosing this. So which availability zone this subnet is? Can you read this? US East 1E. So 1E is the availability zone. You can see this is US East 1B. This is US East 1C. So basically US East 1 is the name of your Northern Virginia region. And ABC later are deciding AZ. This one is US East 1F. This one is US East 1A. So suppose I have selected US East 1A. So they will ask you auto assign public IP. So they are asking you, do you want public IP to be assigned to this EC2 machine? So the answer is yes. We want public IP for this EC2 machine for testing purpose. And for that reason, already enable is selected. So there is no problem for us. It's already enabled. The next question is firewall. For every EC2 server, there is one firewall you can create who can filter the traffic. This firewall is called as security group. This is a new concept that you are learning today. Security group. Security group is a firewall that every EC2 machine has. And you have to configure that firewall. You have to give certain inbound rule for it. For example, right now you can follow me. First of all, you can give some security group name. Do you want to give some name here? Let us give some name. Let's say security group for demo 1. This is the name I'm giving. Security group for demo 1. Next, they are asking you inbound rules. So they are asking you what traffic you would like to allow. So right now, you can choose type as SSH and anywhere. So keep it as it is, don't change it. You click on add security group. So let us add second rule here. Inside this second rule, you will choose type as HTTP and source as anywhere. So you can see my screen, there are two rules. The first rule is SSH anywhere and the second rule is HTTP anywhere. So we are going to allow only two type of traffic to come into my machine. First is people can do SSH, they can do remote login. And second is people can visit our server. And for that purpose, as it is web application, we require HTTP traffic. So if it is done, you can let me know. So our network settings are over. The next option is storage. Inside storage, already one volume is selected. It is called as root volume. You can see here, 1 indicates quantity. This 8 indicates size. And this GP3 indicates type of volume. You can see general purpose SSD, general purpose SSD, provision IOPS SSD, provision IOPS SSD. So basically you have different types of EBS volumes, but by default, the volume that is attached for root volume purpose, it is of 8 GB of GP3 type. So we are happy with this. We are not going to do changes here. Finally, the last option is advanced details. In advanced details, advanced level settings are there. You should know two settings. First is IAM instance profile. So what is this option? for every EC2 machine, for every EC2 instance, there is a concept of instance profile. This is the place where you can add a role. Do you remember service role? In the demo, I shown you how to attach the role after the creation of EC2. Now here, if you know already that this EC2 machine will require a role, then you can select and identify the role that you would like to attach. For example, I would like to attach this sample role for EC2 S3. So that in case of future, if this EC2 machine requires S3 access, then this profile will help it. Right now, I'm just showing you, you can add the role here also. But right now we don't have role, so we will not do anything. You'll simply go down in the last option. The last option is called as user data. This is the option where you can have your user data script written, and what EC2 will do, it will execute those script. So you can write down some bash script here. What you do right now, go to your notepad and you have to select this much. I want you to select this complete script. Can you copy this? Copy this script and paste it here. All right. So like finally, you can see the summary on the right side. Okay, so Arun is saying what that option below, for what purpose? So first question is number of instance. So we are happy with one machine. Linux AMI, T2.micro instance, security group we have created, storage volume of 8 GB we have done, and we have given the user data script. So let us click on launch instance and wait for a moment. So you should get this success message. So you have successfully initiated launch of instance. Okay, so you can click on instance option again and you can see that your machine was in pending state and right now it is showing you running. Can you confirm it is showing you running? So instance state is a state of the machine. You can see stop instance, start instance, reboot. Reboot means restart, hibernate, and terminate. So these are the 5 states of instance: stop, start, reboot, hibernate, and terminate. So when you start your machine, it goes into running state. Running state is the active state of machine. You can access the website on the EC2 only if it is running. So remember, when your server is running, that time only people can access the application. So if I create this machine, I can select and see the details of the machine. Just open it. This is the page for my EC2 instance. I can see a lot of details are there. It has got public IP also. State is running. It has got all the details such as security. So you can see security group here. Storage, you can see EBS volume which is created. So this is the EBS volume which is attached to your EC2 machine. Right now what you do, you just see public IP address. Do you see public IP address? So what you have to do, you have to click on these boxes which will help you to copy the public IP. You need to click on these square boxes. Once you click on these square boxes, open the tab and paste that number and see. I got connected to the website on my EC2 machine. From my local computer, from my browser, I could visit the website on EC2. I can see the content of website, hello world. If you see the script, you can see that the last statement. We are having index.html. In that index.html, we are going to print hello world example. So we are expecting to run index.html, and for that purpose we are using HTTPD server. HTTPD is a web server on EC2 machine. You need to install it. So we are installing HTTPD server, Apache server. On that we are putting index.html, and that index.html is having this statement hello world, and you can see this. So as per my architecture, from the public internet, can we access the website on EC2? We have learned how to give user data script and install the application. Now we'll go with the second option, remote login. How can we install application by doing remote login? So this is the demo number 2. First of all, you will go to your EC2 page. You will click on left hand side on instances option. All right, you can see your one machine. You need to click on launch instance. You can give a name as demo machine 2. So I'm creating second machine right now by giving a name as demo machine 2. And here the operating system, already Linux is chosen. So I don't think you need to change anything. First give it a name. Second, for operating system AMI, already Linux is selected. You can see here Amazon Linux 2023 AMI is already selected. Even instance type is also T2.micro. So that instance type is already selected. Next question is key pair. And this is very important this time. In your second demo, when you want to do remote login, even it is written in the bracket also, login is written. So if you want to do remote login, then you require a key pair. And what is this remote login concept? I will explain you right now. So remote login is a method which is used by developers to install anything afterwards. So let us take this example. Okay. So you can see that this is blue color person is a developer. This blue color person is not end user. This red color is end user. He is visiting website. But this blue color person is developer. Suppose developer wants to log in inside the EC2. I'm saying login. I'm not saying visiting AWS or visiting website. He is not visiting website. He wants to log in EC2 from his local computer. This is called as remote login. So developers do not need to log in into account, because you can understand login into AWS account is a different story. I'm telling that, can you directly log in into EC2? So EC2 is a server. You can log in inside it. So if you want to log in into EC2 remotely from your local machine, then it is called as remote login process. Do you understand remote login process? It is done by developers so that they can install something on the EC2 machine. It is used in many places. For example, if you want to install application later on, or if you want to update your application, or if you want to update operating system, update or patch, you should require remote login. That developer do not need to visit AWS account. It is not required. They can directly do remote login to the EC2. Only Fahad understood it. What about other participant? I will not proceed without your confirmation. We are doing it practically, no doubt, but I would like to understand whether you got the idea of theory. Okay. So now for remote login, two things are required. Number one, inside your security group, you should allow SSH access. What is SSH? SSH stands for Secure Shell Access. It means for remote login, which traffic should be allowed? SSH traffic should be allowed inside your security group. So this is one thing which is very compulsory. Second thing which is compulsory is you should create key pair. Now what is meant by key pair? That I will explain. Key pairs are used for authentication purpose. So I can explain you key pair with the help of simple example. So this is your EC2 machine, which is inside your AWS. And this is you as a developer in your public internet, right? You will be connecting through public internet. And this is your local machine, your laptop. So what you want? You want to do remote login. And that for that purpose, we are using SSH protocol. So this is possible. Technically, you can do it. But for authentication purpose, because the question is this developer login inside your account? Where do we log in? Are we logging inside the AWS account or inside EC2? So developer will log in directly inside EC2. He will not log in into AWS account. So try to understand. From his local machine, he wants remote login to EC2 machine. So if you want to remote login into EC2, you need to authenticate yourself that you are the right person. Otherwise, anybody can log in into EC2 and they can play around with your server. They can install bad application. They can install some viruses, malware. So EC2 machine, you cannot get login easily. You need to authenticate. For that purpose, key pair is a concept. So what is key pair? When you create a key pair, then this key pair consists of two keys. One is called public key and second is called private key. So what happens? Public key is stored inside your EBS volume, PK. So public key is actually stored at EC2 side, or obviously EC2 side, it will store inside EBS. And private key, PR key. Private key will be stored inside your local machine. So now this is called key pair. Public key goes on EC2 side and private key remains at your local machine. So what you have to do? When you do remote login using SSH, then you have to pass the path of private key. What you have to pass? Path of private key. So basically while login, you are giving your private key and EC2 will check that private key whether it is correct or not correct. If it is correct private key you have passed, then it will allow you to log in. Otherwise it will not. So do you remember some movies where, people want to do some dealing, they want to transfer some parcel. So what they do? They actually cut a paper into two pieces. One piece is at one party, other piece is at other party. So when they actually meet, how can they authenticate themselves? They give the one piece to the other person. The other person will match that piece with your piece that it has. And if the match is found, then he can consider that this is the right person. Similarly, public key and private key are two pieces. So when you do login, you have to pass the private key. And EC2 already has public key. So EC2 can compare private key with public key. And if it finds that it is a right pair, then it will allow you. Simple. Correct? This is the human technology, right? How to authenticate people correctly. So this has been taken into cryptography. I think this example helps you to understand key pair part. Cryptography is inspired from real life, right? So now let us come back into our demo. And what you do, you click on create key pair. You can see this option. Create key pair. When you click on this, then first thing is you need to give a name. So I'm calling it as key pair 9th June. So now click on create key pair. And you will observe that one file is downloaded on your local machine. Can you see that? Can you open that file? So this file is having private key. This file is actually a private key. So Claudia, do you understand private key is downloaded on your laptop? Please respond. Where is the public key? In EBS volume of your EC2. Now, for example, if I know that this file is there in my download folder, I can show you. This KP pair 9 June is inside my download folder. So they will store it in their local system. And if they know the SSH command, they can easily log in. So whoever has this private key, they can log in inside that EC2. Is it clear? This is a conclusion. Whoever has this private key, and I will show you right now. So first of all, key pair part is done. Now go to network setting. We will go with default VPC, no preference for subnet, public IP is enabled. And for security group, we can allow SSH as well as HTTP. SSH is required because we want to do remote login, and HTTP because people want to test whether the website is running or not running. You can click on this checkbox, allow HTTP traffic, and SSH is also. Now for storage, we will not do anything. We will go ahead, and into advanced details also, we will not write anything into user data script. We will not write anything into user data script. We will skip this process and launch the machine. Now tell me one thing, this machine has any application right now? Does this machine has any application right now? No. This machine has no application right now. So it is a blank machine having only operating system. You can check. So once it becomes, right now it is pending. So once it becomes running, you can test whether you get any application or not. So let us find out this demo2 machine and find out the public IP address. I know that there is no server on this EC2, so we get an error. We cannot reach this page. Okay, because we have not installed any application yet. We just have operating system. So now what we will do, we will try to do remote login, but from local machine. For that purpose, you have to open command prompt. If you're using Windows laptop, open command prompt. If you are using Linux or Mac laptop, then go with terminal. Can you check AWS -- version? Can you type this command? AWS space -- version. Do you get CLI version written? I can see that CLI is present in my account. Now what you have to do, first of all, you need to tell me in which folder your file is stored, private key. So can you do CD downloads? So we have to go inside that folder. So we all have to do CD space downloads. My spelling is wrong. CD space download. I have written wrong spelling. So finally what you do, go to your EC2 machine. Come on this page. Here you find connect button. You can see connect button. Click on connect button. It says connect to instance. In connect to instance, you have to click on third option, SSH client. You can see SSH client I have clicked on. And there you find an example. So in the example part, you have to copy this example, SSH -i key pair 9june.pm EC2 user dash. Copy and paste it here. This is the command to do remote login. In this command, the name of command is SSH. -i stands for identification. So it will identify key pair. So the name is also given, key pair 9june.pem. So we are giving the name of the private key. And finally, we are giving username of EC2, that is EC2 user. And this is the public DNS of your EC2. So where we get it? We get it from here. In fact, after the @ you can give public IP also. Instead of this long URL, you can give public IP of the machine also. SSH -I key pair name EC2 user @ EC2 machines public DNS. Can you click on enter? What response you get? Are you sure you want to continue connecting? Is this the question asked to you? Are you sure you want to continue? So can you type YES, yes here? Can you type yes? You can see. Finally, you are permitted. You are permitted and you are logged in inside EC2 machine, which is saying that EC2 user @ IP 172.168.24.12. So you can see the command prompt. You have successfully logged in inside EC2. This is the private IP of the machine. You can cross check. I can show you. This 172.31.24.12 is the private IP. Go back and check. The private IP, you can cross check it. This is 172.31.24.12. And this is what the private IP it is showing. So you have successfully logged in inside EC2. This is what you can do remote login. So after you successfully remote login, you can install your application. So what we can do, you have the EC2 script, right? Here. First of all, you will all copy this particular command. Yum install -y httpd. You can type yum install -y httpd and enter. So it gives you error that this command has to be run with super user privilege. Did you get the error like this? Super user privilege? Because you are EC2 user of Linux. In Linux, there are user-based system. So for your Linux OS, you are EC2 user. They want you to become a super user. So for that purpose, you have to type sudo su. Sudo space su. You need to type sudo, sudo space su and enter. Then you see you got a super user access. So what you will do now, you will again type yum install httpd. Yum install -y httpd. This is the command you can copy from your EC2 script. You can see here this command yum install -y httpd. So once you do this, it will start installing HTTPD server on your EC2 machine. Finally, you get complete message in the bottom. Now you will take next command, systemctl start HTTPD. Systemctl start HTTPD. You can see command number 3 or 4, I think. This one, systemctl start HTTPD. Then systemctl enable HTTPD. Take the last command and run this command here. Echo hello world. Get the public IP of the machine and check now. I can see my index.html is running successfully. Simply you have to execute 4 commands which are given in the user data script. These 4 commands one by one you have to execute. And you can check public IP. You will see that your second machine is having that index.html running. So this is the way we can create one EC2 machine and we can do application installation by 2 methods. One is user data script and second is remote login.
Here we're going to talk about Amazon ECS. a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. I mean, ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. I mean, each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying. You can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users. The end user could be in the internet. The end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now, how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up, and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that, suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you had like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM, or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment the one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. The one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it. So to best use those resources in EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there, right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already, and it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance, and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then elastic network interface card is a virtual interface network that can be connected to an instance in VPC. So in other words, elastic network interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remind and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it a backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure your cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and a bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me. And it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it. And because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 receives information on port 80, HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done, and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created it gets a new IP, right? So hard-coding IP is hard-coding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, the different ways, the different methods you can access Route 53. And finally, we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years, right? And then you will gradually be utilizing it from 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is a highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53, it's highly scalable, meaning suddenly, let's say the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without the users, without you interacting, without the user who bought it interact with it. You don't have to scale up, when you're expecting more requests, it automatically scales. And it is very reliable in a sense that It's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server, to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing, that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency based routing. Just like the name says, we use latency based routing if we have resources in multiple AWS regions, and if we want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of odd resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy, it will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin load balancing. That's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability. Otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these companies are very critical, they're being highly available, their site being highly available and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used. With all the weighted routing, the resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-route53. Let's check its availability. It is available for $12. So let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me, right? Click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step button clicks, and then it'll be done. So I have an domain name bought, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket, static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser. Right, so it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer. And if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about a scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. If you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now, generally, there are two types of environment tier. One is the web and the other one is the worker node. And that's something which we'll be discussing later as well. Now, let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that, you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Gopal, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now, after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons. That's it. Nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now, what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now, in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now, after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and hence monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are 2 types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you 2 different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the clients would be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now, coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now, in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now, obviously, we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client-facing environment. Now, if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service, and you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments, and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now, what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now, in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the auto scaling group. So that's something which we have discussed already. Now, this auto scaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now, what does auto scaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the auto scaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the auto scaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the auto scaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group auto scaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what you have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application, put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed, that there are two types of environments. One is the web server and the one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now, once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now, these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now, either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy our applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now, if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface. And then you have the command references, CLI command references that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups on HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
Moving on to the top 10 cloud computing projects, we have divided this video into 3 parts. The first part is for beginners. Moving on to the first project for beginners, we have a cloud-based file storage. In this project, you will create a simple cloud-based file storage system similar to a Dropbox or a Google Drive. Users can upload, download, and manage files stored in the cloud. The part to create this project will start by choosing a cloud storage service. Select a cloud storage service provider like AWS S3, Google Cloud Storage, or Azure Blob Storage. The next step is creating an account. Sign up for an account with the chosen cloud provider if you don't already have one. The next step is to set up a bucket or a container. Create a storage bucket or container to store your files. The next step is to develop a web interface. Create a web-based interface for users to interact with your storage system. You can use HTML, CSS, and JavaScript for this. The next step is to implement file upload and download. Add functionality for users to upload and download files to or from their storage bucket using the cloud provider's SDK or API. The next step is user authentication. Implement user authentication to secure access to files. You can use services like Firebase authentication or build one of your own. The next step is testing and deployment. Test your file storage system locally, and once satisfied, deploy it to the cloud. Make it publicly accessible if needed. The key learning points of this project is you will learn the basics of cloud storage services, file uploading and downloading, and user authentication. Moving on to project number 2, we have a website hosting service. This project involves setting up an essential website on a cloud platform like AWS, Azure, or Google Cloud. You will deploy a static or dynamic website and make it accessible to users worldwide. Let's move on to the path to create this project. The first step is to select a cloud hosting service. Choose a cloud hosting platform like Amazon Web Services, Azure, or Google Cloud. The next step is to design your website. Create the content and design for your website. You can use HTML, CSS, and JavaScript for static websites or web frameworks for dynamic ones. Then register a domain name. Purchase a domain name from a domain registrar, for example GoDaddy, Namecheap, etc. The next step is to configure DNS. Configure the DNS setting to point to your cloud hosting server's IP address. The next step is to set up a virtual server. Create a virtual server instance on your chosen cloud platform, for example AWS EC2, Azure VM, and Google Compute Engine. The next step is to install web server software. Install and configure web server software like Apache on your virtual server. And the last step is to upload website files. Upload your website files to the server, and then you are done with the project. The key learning points of this project: you will learn how to configure a web server, you will deploy web applications and manage domain names, and finally you will ensure high availability. The next project we have for beginners is a cloud-based calculator. Create a simple web-based calculator application and deploy it on a cloud platform like Heroku. Users can perform basic calculations using this calculator. Let's talk about the path to create this project. You will start by selecting a cloud platform. Choose a cloud platform like Heroku, AWS, or Azure for deployment. Then develop the calculator. Create a simple web-based calculator. You can use HTML, CSS, and JavaScript for this. Then set up a development environment. Install necessary development tools and libraries on your local machine. Then move ahead with version control. Use version control systems like Git to manage your project. Then create a cloud account. Sign up for an account with your chosen cloud platform. Then comes the deployment part. Deploy your calculator application to the cloud platform of your choice. For Heroku, this might involve pushing your code to a Git repository. And then comes the testing part. Ensure that the calculator functions correctly on the cloud server. Let's talk about the key learning points of this project. You will gain experience in setting up cloud server environments, deploying web applications, and understanding server-client interactions. Moving on to intermediate level projects. These projects are for people with decent knowledge of cloud computing basics. The first project we have in this category is an IoT data analytics project. Build a system that collects data from IoT devices, sensors, smart devices, etc. and stores it in cloud databases, for example AWS DynamoDB or Azure Cosmos database. Implement analytics to gain insights from the collected data. Let's talk about the path to create this project. The first step is IoT device setup. Set up IoT devices or sensors to collect data. Then choose a cloud database. Select a cloud database service, for example AWS Dynamo database, Azure Cosmos database for data storage. Then comes the data ingestion part. Write code to send data from IoT devices to the cloud database. Then comes data analytics. Implement data analytics tools or scripts to analyze the collected data. Then comes data visualization. Create visualizations to present insights from the data using tools like AWS QuickSight or data visualizations libraries. And then the last part is monitoring and scaling. Implement monitoring and scaling mechanisms to handle increased data volumes. So let's talk about the key learning points of this project. You will explore IoT data ingestion, cloud database management, data analytics, and of course data visualization. Moving on to the next project, we have a video streaming service. So you will create a video streaming service where users can upload and stream videos from the cloud. Implement features like video encoding, content delivery, and user authentication. Let's talk about the path to create this project. You will start by selecting cloud services. Choose cloud services for video storage, for example AWS S3. For encoding, you can choose AWS Elastic Transcoder, and for content delivery, you can choose AWS CloudFront. The next step is to design the application. Plan the architecture of your video streaming platform, including user interfaces for uploading and streaming. The next step is user authentication. Implement user authentication using services like AWS Cognito. Then comes the video uploading part. Allow users to upload videos to the cloud storage. And then comes the video encoding. Implement video encoding to create different quality versions of uploaded videos. Then comes the content delivery. Use a content delivery network or CDN to distribute videos efficiently to the users. And the last step is testing and scalability. Test video streaming and ensure it scales to handle concurrent users and varying network conditions. Let's talk about the key learning points for this project. You will learn about video processing, content delivery networks, and secure user access control. Moving on to the next project, we have cloud-based e-commerce website. Build an e-commerce platform hosted on cloud. Develop features like product listing, shopping carts, and secure payment processing. Let's talk about the path to create this project. You will start by selecting cloud platform. Choose a cloud platform, for example AWS or Azure, to host your e-commerce application. Then comes the e-commerce framework. Choose an e-commerce framework, for example WooCommerce or Shopify, or build a custom solution. Then comes the product listings part. Add product listings and descriptions with images. Then comes the shopping cart. Implement a shopping cart functionality for users to add products. Then comes the secure payment processing. Set up secure payment processing using payment gateways like Stripe or PayPal. Then comes the user authentication part. Implement user authentication for customer accounts. And finally, the testing and security. Thoroughly test your e-commerce website, ensuring it's secure and capable of handling transactions. What are the key points of this project? You will gain experience in building scalable web applications, handling online transactions securely, and managing customer data. Talking about advanced level cloud computing projects. For advanced level cloud computing projects, you should master cloud infrastructure and cloud services. The first advanced level project we have for today is machine learning with cloud. Develop a machine learning model and deploy it on a cloud server for scalable processing. This project involves working with large data sets and real-time data analysis. The first step is machine learning model. Develop a machine learning model using libraries like TensorFlow or scikit-learn. Then comes the data preparation part. Prepare and clean the data for training and testing. Then choose a cloud machine learning service. Select a cloud machine learning service, for example AWS SageMaker, Google AI Platform, and etc. Then comes the model deployment part. Deploy your machine learning model on the cloud platform. And finally, the scalability. Ensure the model can handle real-time predictions and scale as needed. Let's talk about the key learning points of this project. You will delve into machine learning, cloud-based data processing, and model deployment. The next project we have in this list is the cloud-based virtual desktop. Create a system that allows users to access virtualized desktop environments hosted on the cloud. This project focuses on remote desktop solutions. Talking about the path to create this project, you should start by selecting cloud service. Choose a cloud service for virtual desktop. For example, Amazon Workspace, Windows Virtual Desktop, or Azure. Then comes the configuration part. Configure virtual desktop instances with desired specifications. User management. Create and manage user accounts for accessing virtual desktops. Security. Implement security measures for data protection during remote desktop access. Then comes the access control part. Set up access control policies to restrict user permissions. And lastly, testing. Test the remote desktop access from different devices and locations. Talking about the key learning points of this project, you'll learn about virtualization, remote desktop technologies, and user management in a cloud-based context. Moving on to the third advanced level cloud project, we have a cloud gaming service. Build a cloud-based gaming service similar to Google Stadia. This project involves GPU virtualization, low latency streaming, and multiplayer game server management. Talking about the path to create this project, you should start by selecting cloud infrastructure. Choose a cloud infrastructure. You can either choose AWS or Azure for hosting game servers. Then comes the game server setup. Set up game servers for hosting games. Then comes the low latency streaming. Implement low latency streaming technologies for gameplay. Then comes the multiplayer support. Add multiplayer support for users to play together. Then comes the user management. Create user accounts and manage players' profiles. And finally comes load balancing. Implement load balancing to handle increased player loads. Talking about the key learning points of this project, you will explore cloud-based gaming infrastructure, server management, and real-time multiplayer networking. Moving on to the last cloud computing project, we have a healthcare data management system. Develop a cloud-based system for storing and managing healthcare-related data such as patient records. Ensure compliance with healthcare industry standards, for example HIPAA. Talking about the path to create this project, you should start by ensuring compliance with healthcare industry standards. HIPAA compliance. Understand and adhere to HIPAA compliance regulations. cloud platform selection. Choose a HIPAA compliant cloud platform, for example, AWS Healthcare APIs and Azure for Healthcare. Then comes the data storage part. Create a secure cloud-based data storage system for healthcare records. Then comes the access control. Implement strict access controls and encryption for data security. Then comes the audit trials. Maintain audit trials for data access and modifications. And then at last comes the user training. Ensure staff are trained on HIPAA compliance and data handling protocols. Talking about the key learning points of this project, you will gain expertise in cloud security, data privacy, and compliance while addressing real-world healthcare data challenges. These projects provide a progressive learning path allowing individuals to start with basic cloud concepts and gradually advance to more complex and impactful cloud computing applications. Each project offers valuable experience and skills that can be applied to real-life scenarios and career development in the cloud computing field.
Hello folks, welcome to yet another exciting video from Simplilearn. Are you ready to unlock the doors to a thriving career in cloud computing? The job market for AWS is booming, and companies are on lookout for talented individuals like you. AWS holds a significant 32% share in cloud computing job listings, making it the go-to choice for many businesses. What makes AWS so appealing? Well, it's known for its cost-effectiveness, scalability, and rock-solid security features. However, to stand out and succeed in the job market, it's essential to be fully prepared to ace those interviews. In this video, we have compiled the top 20 AWS interview questions that will not only sharpen your knowledge, but also boost your confidence when facing those crucial interviews.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
But before we get started, if you are interested to dive into the world of cloud and get certified, don't forget to explore Simplilearn's Cloud Architect Masters program. This course is designed to equip you with expertise in AWS, Microsoft Azure, and Google Cloud Platform right from the basics. You'll gain mastery over the architectural principles and services of these leading cloud platforms. Learn to design and deploy highly scalable, fault-tolerant applications and acquire the skills needed to evolve into a proficient AWS and Azure cloud professional. For more information, check out the course link in the description and pinned comments below. So, no more waiting around. Let's get started. As a bonus in this video, along with the top 20 frequently asked questions, we will also cover 5 questions based on case studies that you can definitely expect in your AWS interview. So the first question is, what is AWS and what are its key components? AWS, or Amazon Web Services, is a cloud computing platform offered by Amazon. It provides a wide range of services like computing power, storage options, and networking capabilities. Key components include EC2, Elastic Compute Cloud for virtual servers, S3, or Simple Storage Service for scalable storage, RDS, Relational Database Service for managed databases, and IAM, Identity and Access Management for security. You can also imagine AWS like a huge toolbox which has everything you need to build and run your applications without worrying about the infrastructure. You have EC2, which is like the section for renting virtual computers, S3 for storing your files securely, RDS for managing databases, and IAM for controlling who can access what. Now, what is the difference between EC2 and S3? EC2 provides resizable compute capacity in the cloud, allowing you to run applications. S3, or Simple Storage Service on the other hand, is storage for the internet. EC2 is like having a computer in the cloud, while S3 is more like having a hard drive in the cloud where you can store files. Think of EC2 as a rented computer in the cloud. You can install software, run applications, and do pretty much anything you would do on a regular computer. Now, S3 on the other hand is more like a giant external hard drive. You can store all your files there like images, videos, or backups and access them from anywhere on the internet. Now, let's move on to the third question. Explain the concept of elastic load balancing, or ELB. Now, ELB automatically distributes incoming application traffic across multiple targets such as EC2 instances, containers, and IP addresses to ensure no single resources is overwhelmed. ELB is like having a traffic manager for your website or application. It automatically spreads incoming visitors or requests across multiple servers so that no single server gets overwhelmed. It's like having a multiple cash registers open at a store during rush hour. Let's move on to the next question. What is auto-scaling in AWS? Auto-scaling automatically adjusts the number of EC2 instances in a group based on demand. It helps maintain application availability and allows you to only pay for the resources you actually need. So auto-scaling is like having a magical elastic band around your servers. When there's a sudden spike in traffic to your website or application, auto-scaling automatically adds more servers to handle the load. And when the traffic slows down, it removes those extra servers so you don't waste money on unused resources. Now, describe the difference between IAM users, groups, and roles. IAM users are individuals within your AWS account, while groups are collections of users. Roles are similar to users, but they are meant to be assumed by other AWS services or users for specific tasks. Okay, imagine you're the boss of your AWS account. IAM users are like your employees. They can log in and do stuff, but only what you allow them to. Groups are like teams of users with similar permissions, and roles are like special hats that users or even other services can wear to do specific tasks. Now, the sixth question is, what is Amazon RDS? Amazon RDS, or Relational Database Service, is a managed relational database service that makes it easier to set up, operate, and scale a relational database in the cloud. Amazon RDS is like having a personal database expert on the call. It takes care of all the basic details of setting up, operating, and scaling a relational database like MySQL or PostgreSQL, so you can focus on building your app instead of worrying about database management. Now, explain the difference between Amazon RDS and Amazon DynamoDB. RDS is for relational databases and SQL Server, while DynamoDB is a fully managed NoSQL database service provided by AWS. RDS is like a traditional database with tables, rows, and SQL queries, while DynamoDB is more like a super fast, super flexible storage system for all kinds of data, from simple text to complex JSON documents. It's like comparing a filing cabinet to a magic box that can hold anything you throw at it. Now, what is Amazon VPC? Amazon VPC, or Amazon Virtual Private Cloud, is like having your own private corner of the AWS cloud. It's a virtual network that you can set up and customize to keep your resources isolated and secure. Think of it as creating your own little neighborhood within the vast city of AWS. Now, what is the difference between public and private subnets in Amazon VPC? Imagine public subnets are houses with doors facing the street. They're directly accessible from the internet. Private subnets, on the other hand, are like houses with backyard entrances. They're shielded from direct internet access, making them perfect for storing sensitive data or running internal services. Moving on to the 10th question. How does CloudFront work and what are its benefits? CloudFront is like having a network of delivery trucks all around the world, ready to bring your content closer to your users. When someone requests a file from your website or application, CloudFront finds the nearest delivery truck or edge location and serves the file from there, reducing latency and speeding up the overall experience for your users. Now, what is the difference between Amazon S3 and EBS? Amazon S3 is a giant storage locker in the cloud where you can dump all your files and they'll be safe and accessible from anywhere. EBS, on the other hand, is more like renting a hard drive that you can attach to your virtual server. You can install your operating system and applications on it just like you would do on a regular computer. Now, the next question. Explain the difference between the stop and terminate actions in EC2. When you stop an EC2 instance, it's like putting your computer to sleep. All the data and settings are saved and you can start it back up later without losing anything. But when you terminate an instance, it's like shutting down your computer and throwing it away. You lose everything and you can't bring it back. Now, what is AWS Lambda and how does it work? AWS Lambda is like having a team of tiny workers waiting in the cloud to execute your code whenever you need them. You just upload your code to Lambda, define when you want it to run, and Lambda takes care of everything else. Scaling, monitoring, and billing you only for the compute time you actually use. So let's move on to the next question. How do you secure your data at rest in AWS? Think of securing your data at rest like locking it in a safe. AWS offers various encryption options to keep your data safe from prying eyes, whether it's stored in S3 buckets, databases like RDS, or even on your EBS volumes. You can use AWS managed encryption keys or bring your own keys for added security. Moving on, what is CloudFormation and how does it work? CloudFormation is like having a blueprint for your entire AWS infrastructure. Instead of manually setting up each resource, you define everything you need in a template file using simple JSON or YAML syntax. Then, with a single click, CloudFormation creates and configures all the resources for you, saving your time and ensuring consistency. Now the next question, explain the differences between Amazon S3, EBS and EFS. Amazon S3 is a versatile storage solution for the files of all types, accessible from anywhere. EBS or Elastic Block Store is more like a traditional hard drive attached to a single EC2 instance, perfect for storing data that requires low latency access. Now, EFS or Elastic File System, on the other hand, is like a shared network drive that multiple EC2 instances can access simultaneously, making it ideal for shared file storage across multiple instances. Now, what is Amazon SQS and how does it work? Amazon SQS or Amazon Simple Queue Service is like having a virtual queue for your messages in the cloud. When one part of your application sends a message, SQS holds onto it until another part of your application is ready to receive and process it. It helps decouple different components of your system, making them more resilient and scalable. Now the next question is, what is the difference between Amazon S3 and Glacier? Amazon S3 is like having a storage locker where you can quickly access your files whenever you need them. Glacier, on the other hand, is more like putting your files in cold storage. It's cheaper but slower to retrieve. It's perfect for data that you don't need to access frequently, but still want to keep for archival purposes. Now, what is AWS Elastic Beanstalk? You can relate AWS Elastic Beanstalk to a personal chef who takes care of all the cooking and serving while you focus on enjoying your meal. So it automates the deployment and management of your web applications, handling all the heavy lifting of provisioning servers, load balancing, and scaling. So you can just upload your code and let Elastic Beanstalk take care of the rest. Now coming to the last question on our list, how do you monitor AWS resources and services? Monitoring AWS resources can be explained as having a dashboard that shows you how your applications and services are performing in real time. AWS offers various monitoring tools like CloudWatch, which collects and tracks metrics, logs, and events from your resources, and AWS Trusted Advisor, which provides recommendations for optimizing your AWS environment based on best practices and cost efficiency. And that wraps up our rundown of the top 20 AWS interview questions. But wait, let's have a look at those 5 bonus questions now. Number 1, you are setting up a website for a small shop using AWS. How would you choose the right AWS tools to make sure the website stays fast and reliable, whether there are only a few visitors or a lot of people shopping at once during a big sale? Your second question, imagine you are like a tech detective investigating why a website's database is slow for a busy online shop. How would you use AWS tools to find out what's causing the problem and make the database super fast again? Number 3, as the hero for a startup, your mission is to control their AWS costs while still allowing them to grow. How would you do this, making sure they can expand without spending too much money or slowing down their operations? Now your fourth question, a non-profit organization needs help migrating their data to AWS. What steps would you take to ensure a smooth transition, considering their limited budget and technical expertise? And the last question we have, a startup wants to store their customer data securely on AWS. How would you recommend they do this, considering both cost and security? Try answering these questions in the comment section. Let's have a discussion there.
That's a wrap on our AWS Full Course. If you have any doubts or questions, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.